Audio is important. I think we all know that. But I think that audio is more important than video. If you have a video that has a great picture but poor quality audio, I think you're going to lose your audience. On the flip side, poor quality video and stellar audio is much more tolerable. For things like news, review, opinion, and other informational content, you can transmit most of the information without actually looking at the screen. It's almost impossible to do the opposite without turning on captions. For example, watching this video with the audio muted without captions is almost pointless because so much of the story and information is told with sound. And audio's importance goes far beyond transmitting information via someone talking. Music, sound effects, and ambient sounds help to establish mood, pacing, and give weight to visuals that would otherwise fall flat. Hi, my name is Dave Bodie for Envato, and in this course, you are going to learn how to edit audio for video. To start, you will learn about the goals for editing audio monitoring with headphones, speakers, and a subwoofer. Then I'm going to dive into Premiere Pro and Audition, and you will learn about the audio processing order in Premiere, syncing audio to video, how to level clips, basic denoising in Audition, fixing audio drift, the basic effects chain for voice, including denoise, EQ, dynamics, and de-essing, mix or master track effects, third-party audio effects for master track and dialogue, de-clicking, de-reverbing, multi-person interview mixing, mixing music against dialogue, editing music with remix, editing music manually, using submix tracks, and I'll give you an overview of a project that I mixed and mastered in Reaper that contains music, voiceover, and sound effects so that you can get an idea of a more advanced routing and mixing process. Throughout this course, you will see real-world projects containing footage from Blackmagic cameras, Zcam cameras, and stock elements from Envato Elements. With Envato Elements, you get access to millions. That's right, millions of creative digital assets for one low price. I'm talking about stock footage, motion graphics templates, music, sound effects, photos, vector graphics, fonts, After Effects templates, and so much more. A single subscription gives you access to everything that you need to create great projects. See for yourself at elements.envato.com. At the end of this course, you will be armed with a set of skills and knowledge that will help you to tackle editing and mixing audio for video. Let's talk about some goals for editing audio for video coming up next. As someone who is editing audio for video, what are your goals? Here are a few areas that you might focus on: denoising, balance, dynamics, and loudness. Let's talk about denoising. Take a simple example of a person talking. That person was recorded with a microphone, and there's almost always a bit of noise in the recording. Sometimes it's a voiceover recorded in a studio, and the noise is so low that it's not a problem at all. Other times you might be working with a clip recorded outside or on location, and outside of a heavily treated studio space, the noise will become more of an issue because noise makes the messaging of the video less clear. So part of the audio editing process is cleaning up noise in recorded audio. This could be ambient noise from an appliance or a machine, electronic noise like a preamp being turned up all the way, or noises in the background like a dog barking or a door closing, for example. If you can reduce the noise, it makes the messaging clearer. The term balance covers three areas: frequency balance, level balance, and pan balance. Frequency balance is the idea of equalization, which is the process of adjusting the volumes of different frequency bands within an audio signal. And this is a very common idea that almost everyone is familiar with, even if you haven't edited audio before. Perhaps you have listened to music in the car or on a Bluetooth speaker, and you've adjusted the treble or the bass. That is equalization, or EQ for short. And EQ can be done just about everywhere to correct or enhance the audio. Level balance is the idea of moving some things to the foreground and other things to the background by adjusting their volume. This is often called mixing. You take two or more sources and combine them together and balance their levels via volume controls. Learning how to do this comes from time and experience, but Adobe has some tools that will make some of those tasks a little bit easier, like balancing music against dialogue, for example, which you'll see in an upcoming lesson. Finally, there is pan balance. Panning in audio is the distribution of an audio signal into a stereo sound field determined by a pan control setting. Stereo has two channels of audio, one for the left and one for the right. With panning, you can decide the balance for each sound. For example, if you have a visual effect that is on the left side of the screen and you have a sound effect to go with that visual, it makes sense to put a little bit more of that sound effect on the left side via the pan control. Now, for simple videos, you might not need to do any panning, but as your videos get more complex with sound effects or multiple people talking, panning can help increase clarity and reinforce what the audience is experiencing. Now, just a side note, this course is only going to be covering mixing for stereo, which is what you will find all over the web. Multi-channel audio, like 5.1, 7.1, or other surround sound formats, is another animal entirely. It requires a much more complex monitoring system and is way outside the scope of this course. All right, let's talk about dynamic range. Dynamic range is the difference between the highest signal and the lowest signal. However, a better way to think about it might be to think about the difference between the peak levels and the average levels. Thinking about dynamic range this way aligns a little bit better with how we perceive loudness, which I'm going to talk about in a minute. In a simple example of a dialogue track, you might want to reduce the dynamic range to make it more comfortable to listen to. If some of the words of the speaker are too low in level, it makes our brains work harder to understand them. Similarly, if a speaker is fairly consistent but has a very loud laugh or shouts about something, that can be a bit jarring and uncomfortable to listen to. So, controlling the dynamic range, sometimes shortened to dynamics, is a way to make dialogue, for example, easier to listen to. Sometimes it's as simple as increasing the volume of a track, but only on a few words that are just too low, perhaps at the end of a phrase. Or it could be using an audio compressor to take down some of the peaks and bring them lower, and then increasing the overall volume. Or it could be a combination of both techniques, and you will learn about volume automation and audio compression in an upcoming lesson. Finally, there is loudness. Loudness is important. I think we all know that. If your project is too quiet, it's difficult to listen to, and that's not good. But if it's too loud, it could cause clipping or sound distorted, which is also not good. So you want your project to be loud enough, but not too loud. And how loud is loud enough? That's a good question. And that's something that I'm going to talk about coming up in the next lesson. In this lesson, you are going to learn about loudness. Loudness is a helpful measurement tool that you can use to balance voices, output audio that is very consistent, and meet specifications set by distribution platforms. But what is loudness? Loudness is a way to measure audio similarly to the way we perceive sound. I know, this seems like such an obvious thing, but for decades, a VU meter or peak meter and experience were used to judge loudness. Those types of meters are the digital equivalent of a voltage meter, and they display the amplitude of the signal. In other words, these types of meters show how much signal there is, but not what it actually sounds like. Loudness meters, on the other hand, analyze audio levels over time with a particular frequency weighting, and this mimics how we perceive loudness. Frequency weighting means that, well, certain frequencies have more weight and others have less weight. Again, this matches how our own hearing works. We are more sensitive to higher frequencies compared to lower frequencies. For example, a 6 decibel increase at, let's say, 3 kilohertz will be perceived as louder than a 6 decibel increase at 50 hertz. So changes in higher frequencies will move the loudness meter more than lower frequencies. Loudness is measured in LUFS, which stands for Loudness Units Full Scale. The term full scale references the highest a signal can get, and in digital audio, that is 0 decibels. And because 0 decibels is the limit, all of the loudness measurements are negative. For example, the recommended loudness for YouTube is negative 14 LUFS. For broadcast television, it's negative 23 or negative 24, depending on Europe or North America. The main difference between these two levels, negative 14 and negative 23, are the average levels over time. A YouTube video, for example, will have higher average levels compared to broadcast TV because it needs to be louder because of how the content is consumed. So if your project is not quite loud enough, what can you do to hit your target loudness? Can you just turn up the volume of all your tracks? Yes, you can, but you're gonna run into some problems at some point because digital audio has limits. You just learned that the maximum amplitude in digital audio is 0 decibels, and everything below that is a negative value. This means that all of the audio in your project lives in this space where 0 decibels is at the top, and the bottom is as low as the bit depth allows. For example, a 16-bit audio file has 96 decibels of dynamic range, and a 24-bit file has 144 decibels of dynamic range. Now you might be thinking, 144, that's going to be louder because 144 is more than 96. And that's true, but think of it as 144 decibels below 0. So what that means is that a 24-bit file can store things that are quieter than a 16-bit file. Now in the real world, the differences between 24-bit and 16-bit are not as big as the theoretical dynamic range values would indicate. And it doesn't really matter why, because in most of your projects, you are going to be working with a much more limited dynamic range. The point is that 0 decibels is the limit. Now, audio that goes above 0 decibels is going to be cut off or clipped, and this does not sound good and should be avoided. So when you are managing the loudness of your projects, you can use some tools to compress the entire mix as well as individual tracks to decrease the dynamic range, and then use a limiter on the mix or master track. This way, as you push the volume level up of your tracks, the peaks will never get to 0 decibels. They'll get close, but they'll be smoothly turned down by the limiter and the other compressors. With a loudness meter, you can monitor how loud your project is and then use that information to make decisions about how to process your audio. If you are outputting to something like YouTube, for example, and you see that your loudness is a good bit lower than the YouTube recommended loudness, you can apply some mix track processing to make up the difference or increase the volume of certain tracks, or a combination of several things to get the loudness to where it needs to be. Throughout this course, I will be talking about the YouTube recommended loudness level of negative 14 LUFS. This is because, well, YouTube is the biggest platform out there. And the recommended loudness level for YouTube is what it is because of how the content is consumed. And I think that's important when we're talking about loudness. YouTube and similar platforms are watched primarily on mobile devices. A mobile device means two things. First, it will have a limited output capability, especially if it's using the built-in speaker on the device, like a phone or a tablet. In other words, the tiny speaker just can't output a lot of sound pressure. The second thing is that it might and probably will be heard in an environment that has higher ambient noise levels compared to your very quiet bedroom, for example. In the car, on the street, in a bus, or outside. This means that in order for the audio to be at a comfortable listening level, audio for YouTube and similar platforms needs to be louder compared to, let's say, broadcast TV or a movie. And louder means that it has to have higher average levels and less dynamic range. Now, some platforms, like YouTube and others, will process the audio when you upload a video to make sure it's hitting the target of negative 14 LUFS so that all of their videos sound consistent. But just because YouTube will process the audio doesn't mean that it will, well, sound good or consistent or comfortable to listen to. You really need to actively monitor the loudness of your projects and get a bit hands-on with the process and, well, processing of the audio for best results. Now, there are some tools that will help you to hit a specific loudness target very quickly. For example, in Premiere, you can process the audio to hit a specific loudness target when you export. And in Audition, you can use a process called loudness match. But I don't think these methods sound as good as taking the time to mix and process the audio yourself. With a little bit of mixing and processing, you can create videos that hit your loudness target while also sounding good and very consistent. In an upcoming lesson, you will learn exactly how to process your tracks so they sound super consistent using track effects. Now, coming up next, you're going to learn a little bit about gain, level, and volume. In this lesson, you will learn about gain, level, and volume. I want to take just a few minutes to talk about these terms because for someone who is new to audio, I think they can be a bit confusing. Gain, level, and volume all refer to the same thing, and that is the amplitude of the signal. All throughout the audio world, these terms are used in both hardware devices and in software. And sometimes software and hardware makers will use these terms somewhat interchangeably, which I think is unhelpful. Generally speaking, the word gain is usually used at the beginning of the signal chain, volume is used more at the end of the signal chain, and level is used to describe how much signal there is at various points in the signal chain. This isn't always the case, but this is mostly how it works. In this course, I'm going to be working mostly in Adobe Premiere Pro. And in Premiere Pro, there are various stages where you can change the amplitude of your audio. Now, sometimes the control for doing that is called gain, sometimes it's called volume, and sometimes there's a control called volume level, or maybe just level. Now, I tried to work out a clear way to explain why this is, but I can't. All I can say is that some applications use the word gain because that is what it might be called in the analog world. For example, on a mixer or a recorder, if you want to increase the signal coming into that device from a microphone, you adjust a control called gain. This controls the amount of amplification from a circuit called a preamp. In Premiere Pro, for example, if you want to increase the amplitude of an audio clip in the timeline, you do so with the audio gain command. Audition and Pro Tools call the same action gain or clip gain. Now, because this is a digital adjustment, there isn't an amplifier circuit being used, which is what the word gain is almost always referring to in the electronics world, but functionally, it's doing the same thing. In other words, increasing the gain of an audio clip in the timeline via the audio gain command or whatever it's called in another application is just like having recorded the clip with more gain on the preamp. Now, having said that, there are other apps like Reaper that call this same function of increasing a clip's amplitude clip volume. And other apps may use slightly different terminology. So like I said before, it can be a bit confusing, even for me. Now, throughout this course, you might hear me say something like, I need to increase the level, or turn up the volume, or bump up the gain. All of those phrases mean the same thing, and that is changing the amplitude in some way. And the actual controls may be called gain, volume, or volume level inside of Premiere Pro. When you see it in context, it's going to make sense, but I wanted to briefly explain those terms now before moving forward. All right, coming up next, you're going to learn about audio monitoring with headphones. In this lesson, you will learn about headphone monitoring basics. In order to hear what you are editing, you need some kind of audio monitoring system. The goal for audio monitoring is a very flat frequency response that can get adequately loud with very low distortion. If your audio monitors have any large deviations in frequency response, you will likely compensate for that by EQing your tracks in a way that, well, you probably shouldn't. For example, if your speakers or headphones have an elevated response at 5 kilohertz, that might sound a little bit harsh, and you will be inclined to reduce 5 kilohertz in every mix when you shouldn't. So a flat frequency response is the goal for speakers and headphones. But a flat frequency response is harder than it sounds because to get a speaker to be razor flat, it's usually pretty expensive. But I know you're thinking, okay, but what if we made the speakers really small and you put them right by your ears? Yes, headphones are an option. I like to say it is an option, but I don't think it's the best option. I have and use headphones, but I don't do critical mixing on headphones. However, it might work for you, so let's start there. Headphones are the easiest and least expensive way to get high-quality audio monitoring. You don't have to deal with room acoustics. They're relatively small and portable, and they don't take up hardly any space in your room. There are a few downsides, though. First, unlike speakers, only you can hear your mix with headphones. Now, if you never have to play your mix for a client in the same room, no worries, you're good to go. But if you do, you're also going to need a set of speakers. One thing you miss at higher volume levels on headphones is the physical interaction of the low frequencies with your body. If I push up my main monitors here up into the 85 to 90 decibel range, I can feel the kick drum of a music track hit my body. That feeling does not always translate when using headphones. Additionally, headphones are not exactly stereo. Hang on, you're saying. Headphones have a left and a right channel, and left and right is stereo. This is true, but headphones are not the same as listening to stereo loudspeakers because your left ear only hears the left channel with headphones and vice versa for the right. Dan Worrall has a great video explaining this in more detail, and you can find that on YouTube by searching Dan Worrall, Headphones Are Not Stereo. It's a great video. Check it out. Now, all that being said, there are some interesting tools out there that can take lower cost headphones and make them behave more like high-end headphones and even simulate mixing on speakers in a room. A company called SonarWorks has a product called Sound ID Reference, which is software that can apply a frequency correction curve to compensate for a headphone model's natural frequency response. SonarWorks measures headphones and then creates a correction to get the frequency response more flat. Sound ID can also simulate playback on other devices like studio monitors, cars, smartphones, and more. I tried a demo of this software, and honestly, it wasn't for me. The correction curve didn't sound right with my headphones, which are supported. I just thought the correction curve didn't sound as, well, correct as I thought it should have. The thing that I did like about the software is that it creates a virtual sound device on your system. And that means that anything that you play on your system, whether it's in an application for video or, well, any app, gets processed, and you don't have to run any additional effects on your mix or your master bus. I really like this feature, and I got the whole thing set up and configured for my headphones in less than 2 minutes. Now, they have a free demo, so it might be worth checking out for yourself. Another option is Morphit by Tone Boosters. Morphit is a frequency response correction plugin with support for 400 plus headphones, somewhat similar to Sound ID Reference. I found the correction curve to be better than Sound ID. In fact, it's something that I would actually use, and I did buy it when I tested it. You can run Morphit on system-level audio on Windows using a free app called Equalizer APO. With Equalizer APO and Morphit, anything you play on your computer is corrected for your headphones, just like Sound ID Reference. I do believe that there are tools that can do something very similar for the Mac, that is running VST or AU plugins on system-level audio, but all of my main workstations are PCs, so I'm not as familiar with those apps. Now, I just want to say that I'm not recommending or advocating that you need any of these tools. No one paid me to say that, I'm not sponsored by them, but I wanted to let you know about them because if you're not satisfied with the way that your headphone mix is translating to speakers or other devices, these apps might be worth a look. Also, as a bit of a warning, if you set these apps up so that they process the audio on a system level, anything you play will have that correction curve applied to it until you disable the correction. Now that means that if you're going back and forth between headphones and speakers, you're going to want to disable the correction when you're listening to speakers, or your speakers are not going to sound correct. Now, over the years, I have tried headphones from AKG, Audio-Technica, Sennheiser, Sony, Shure, Beyerdynamic, Corsair, and others. Many headphones sound good, But not all headphones are comfortable to wear. And I think comfort, in this case, is a little bit more important than sound quality. If a headphone sounds perfect, but puts too much pressure on your head or your ears, or is really hot and causes you to get all sweaty, that's a deal breaker in my book. It's probably better to get a headphone that you forget you're wearing because it's so comfortable, and then tweak the frequency response with software if you really need to. And again, you don't need to in every case. In general, I believe that you'll find circumaural headphones the most comfortable. Circumaural headphones are headphones that completely surround the outer ear instead of pressing on your ear. In other words, this type of headphone doesn't touch your ear at all. And this is really important if you wear glasses. Circumaural headphones come in open and closed back designs. With closed back, none of the sound escapes, or almost none of the sound escapes, because the back part of the speaker is sealed or closed. With an open back design, the back of the speaker is more open, and some of the sound is audible to others around you when you are wearing them, although it's pretty minimal. This also means that open back headphones do not block outside noise. This is kind of a pro and a con. If you are wearing these headphones to block noise, well, open back headphones are useless. But conversely, open back headphones allow you to talk to people in a way that doesn't cause you to shout at them like you might with a closed back design. If you're doing any kind of voiceover or podcast work where you are recording yourself or others in the same room, a closed back design is probably the best choice because it isolates the sound more than an open back. On the other hand, open back headphones might be more comfortable because they can let some of the heat escape. And I think in general, they're probably just a touch lighter on your head. Headphones that I use include the Sennheiser HD598 and the HD580X Jubilee from Massdrop. These Sennheiser headphones are so comfortable. I can, and I'm not joking, wear them all day without a problem. Now, neither the 598 or the 580X is a high-end expensive headphone, but they sound pretty good to me, and with Morphit, I think they sound even better. Now, what about a headphone amplifier? Depending on the headphone and what you're plugging them into, you might, but probably and definitely don't, need an amplifier. You can test out whether or not you need a headphone amp yourself. Take your headphones, plug them into your device, and turn up the volume to the loudest level that you are comfortable with. If there's room to turn the volume up more, you probably don't need an amplifier. If you turn it up all the way and it's still not loud enough for you, there could be a few issues going on. First, you have hearing loss, so you're going to want to get that looked at. Second, your headphones are broken, so try another set. Third, the amplifier lacks the power to drive those particular headphones to the level that you require, and only then should you consider a headphone amplifier. All right, that's my hot take on headphones. Let's talk about speakers coming up next. So now let's talk about speakers. A speaker, sometimes called a studio monitor, needs to be able to play back audio at relatively loud levels, have low distortion, and a very flat frequency response, just like headphones. Now, I'm not going to tell you what speakers you should buy because lots of companies make really good speakers that will be appropriate for your budget and skill level. Genelec, Kali Audio, JBL, Yamaha, Focal, doesn't matter, pick one. What I want you to learn in this lesson is this. Studio monitors are not going to give you the best results unless you focus on placement and acoustic treatment. And that's putting it pretty nicely. Speakers interact with your room, and by the time the sound reaches your ears, the frequency response is all over the place, and you're hearing this time delay. So first, let's talk about placement. Getting your speakers placed optimally in your room can make a massive difference in how they sound. Now, I can't tell you everything there is to know about speaker placement, but here are some general things to think about. Place them symmetrically in the room, get them off of your desk and onto stands, maybe with isolation pads, elevate them so that the tweeters are at ear height, and calibrate them with a measurement mic and software. Now, there are 2 links in the description that will go into more detail about how to set up your speakers in your room. Follow the advice. It really makes a big difference. The other thing that is super important, and something that you will see mentioned in almost every article on speaker placement, is acoustic treatment. Now, the kind of acoustic treatment that I'm referring to is not for preventing sound from escaping your room. This kind of acoustic treatment that I'm talking about is for attenuating or absorbing the sound coming from your speakers that radiates all around and bounces off the surfaces in your room. Now, just like with speaker placement, I can't distill everything that there is to know about acoustic treatment in a short little video, but here are some things to focus on. First, remove early reflections by creating something called a reflection-free zone, or RFZ. Now, if you sit at the listening position and you have another person hold a mirror flat to the wall, anywhere that you can see a reflection of your speakers in the mirror is an area where you need to put acoustic treatment to kill those early reflections. This is what I consider to be the bare minimum for acoustic treatment, and it should make a massive difference to the intelligibility of your speakers. Now, treating the RFZ might take as many as 8 2-foot by 4-foot panels using something like 2-inch compressed mineral wool or compressed fiberglass insulation. This style of panel is called a broadband absorber. 2 inches of absorption from these materials will be effective from about 125 Hz and up, although its effectiveness at 125 Hz is only about maybe 40%. Thicker panels will absorb more lower frequencies, and that's always a good thing. Foam panels are not the best for absorption. Foam is not really effective below like 2 kilohertz, and getting panels that can absorb down to 250 or 125 Hz is a much better option, and it's just not as easy to do that with foam compared to mineral wool or compressed fiberglass. So after you treat the RFZ, you can look at covering other areas of the wall to cut down on things like flutter echo and other reflections. And you can alternate the panels between parallel walls so that the room sounds symmetrical. That way you don't have all of your panels on, let's say, the left wall, leaving the right wall completely bare, because that's probably not going to sound that great. You could also think about treating the low frequencies in the room as well. The idea here is to stop the low frequencies from reflecting around and to try to get them to decay faster. Low frequencies are the most difficult and the most expensive to try and tame because it takes a lot more material to stop low frequencies. I'll put a link for how to approach this in the description below. The main point here is this. First, create an RFC, which will probably take at least 8 panels. Then place additional panels around the room to cut down on flutter echo and other weird reflections. If you have the budget, go big and trap bass. Now, I made all of my panels for a fraction of the cost of buying panels, and they are exactly the same as the panels that you can buy. They all use compressed mineral wool. Now, I fully understand that making panels is not for everyone. In fact, it's probably not even for most folks. But I want to mention it because making panels is really not that hard. And if you're going to do acoustic panels, more is always better. So if you can afford to buy 8 panels, you can probably build maybe 16 or more for about the same price. Finally, let's talk about some specifics when it comes to speakers. There are many fine products that are marketed as studio monitors. The most popular are active speakers with a tweeter and a single mid-woofer with a diameter between 5 and 8 inches. Active means that the speaker has built-in amplification. More advanced models also include DSP, or digital signal processing, to limit the output in order to protect the speaker's components and prevent high levels of distortion, and also correct for the speaker's frequency response so that it is very flat. But like I said before, once you put it in your room, it's not going to be flat, but starting with a flat speaker is good. Now, like I said before, many of these studio monitors from companies like Genelec, Kali Audio, JBL, Yamaha, Focal, and many others sound very good, but they don't cover the entire audible range. Now, I looked at all of the best-selling studio monitors, and none of them have a lot of output below 45 Hz. Many will list a frequency response lower than that, perhaps down to, 35 hertz, but that's usually a negative 10 decibel rating. This means that the frequency response is flat, maybe plus or minus 3 decibels down to 45 hertz, and then at 35 hertz, the level is down by 10 decibels, which is really significant. Now, having speakers that go down to 45 hertz and then taper off from there is pretty good for general mixing, maybe dialogue-only projects. But if you want to be able to hear and monitor what's happening in the very low frequencies, you're going to need a subwoofer. And you're going to learn more about that coming up in the next lesson. In this lesson, you will learn about using a subwoofer. A subwoofer is a specialized loudspeaker that produces low frequencies in the range of 20 to 200 hertz. They fill in the low frequencies that small speakers can't cover. And I bet you're wondering, are my speakers small? Yes, they are. Even relatively large studio monitors like these cannot produce sounds all the way down to 20 hertz, at least not at any meaningful levels. If someone could make a two-way studio monitor like this, which is a tweeter and a woofer, cover the entire audible range at a loud listening level with a flat frequency response and low distortion, everyone would be doing it. But here's the thing, no one is doing it because it can't be done. Now, there are some large and rather expensive studio monitors that can get into the subwoofer range, but those are essentially a subwoofer that's glued to a two-way or three-way speaker. The best option for most folks, including myself, is a separate subwoofer and a pair of two-way speakers. This is relatively low cost, and with the right subwoofer, very high performance. Now, here's the big question. Do you need a subwoofer? Maybe. Do you use music or sound effects? If so, I'd say you'd benefit from having a subwoofer. Using a subwoofer has several advantages. Like I said before, with a subwoofer, you will now be able to hear frequencies where you couldn't before. So when you're mixing things like sound effects, your whooshes, your booms, your explosions, maybe your gunshots, etc., you don't have to guess what's happening below 40 hertz. Using a subwoofer will also allow you to get better performance out of your studio monitors. The best-selling studio monitors are in the 4 to 5 inch woofer range. Now, those size speakers do an okay job down to maybe 100 hertz, maybe even 80 hertz, but below that, they have to work really hard to produce higher levels of sound pressure. The content below 80 hertz gets sloppy really quick, and things like port noise and distortion become problematic. Using a subwoofer removes the burden of those low frequencies from the speakers. This will improve the distortion and also the upper limits of output from your main speakers. In other words, you'll be able to play your speakers at the same level or even louder with less distortion. Now, maybe you're convinced at this point that you need a subwoofer. What are you going to get? Things like size, price, power, and quality are all going to factor into your decision. Although I can't tell you exactly what to buy, I do have a bit of advice. Don't, under any circumstances, buy a studio subwoofer. The subwoofers that are marketed to pair with studio monitors, as in the matching subwoofer that goes with your particular monitors, those are not really subwoofers. They're more like very low bass units. Studio subwoofers just don't go low enough because the boxes and the speakers or the drivers are just too small and they don't have a ton of power. Physically, they just can't play in the same space that a subwoofer can. What I would recommend is that you get one from a company that makes high-quality home theater subwoofers like SVS. High-quality home theater subwoofers can reach way below studio subwoofers all the way down to 20 hertz and below at very high output levels with very low distortion. I have two subwoofers from SVS, one out in my living room and one in my office here. The subwoofer in my office is an SB2000 Pro with a 12-inch driver, a 550-watt amplifier, inside of a sealed enclosure with onboard DSP that you can control with an app. And you might be thinking that 550 watts RMS, 1500 watts peak is way overkill, but it's not. subwoofers need a lot of power to create high levels of low-frequency content at low levels of distortion. A sealed subwoofer, like I have here in my office, is smaller compared to a ported subwoofer, and it doesn't offer the same super low tuning that a ported subwoofer does. But I think for a lot of smaller rooms, they're probably a better fit. And with a large driver and significant power like this SB2000 Pro or even the SB3000, you're not going to be complaining anytime soon. Using a subwoofer requires a little bit more setup compared to using just a pair of speakers. Most subwoofers will have something called a low-pass filter built into the amplifier so that you can send it the same signal as your main speakers, and it will filter out all of the high frequencies. However, you're going to need a device to remove the low frequencies from your main speakers. The easiest way to do this is with a digital crossover. With a unit like this mini DSP, you can select the crossover point for your main speakers and then match that to your subwoofers. For example, I have my main speakers crossed over at 80 Hz. Everything above 80 Hz goes to my main speakers, and everything below 80 Hz goes to my subwoofer. 80 Hz is a pretty common subwoofer crossover frequency because at that point, it's more difficult to tell where the bass is actually coming from. And that's a good thing because you'll never notice that the subwoofer content is coming from a speaker in the corner of the room. Using a DSP unit will also allow you to apply some corrective EQ and other processing to your speakers if you use something like a measurement microphone and some free software. The idea is, once you get your speakers optimally placed, you can use the measurement microphone and measure the response at the listening position, and then make some corrections to flatten out the frequency response. Now, this sort of corrective EQ should only be done after you get your acoustic treatment sorted out and your speakers placed properly. If you try and do measurements without acoustic treatment, the room is really going to have much more of an effect on the measured result. Acoustic treatments will reduce a lot of the room response and allow you to achieve much better results. That isn't everything there is to say about using a subwoofer with your main speakers, but I think that's enough to get you started. Be on the lookout for some follow-up videos that go into more detail about how to use a subwoofer with your main speakers. And check the link in the description for more information on SVS subwoofers. All right, coming up in the next lesson, you're going to learn about my three-prong approach for editing audio for video. In this lesson, you are going to learn about my personal three-prong approach to editing audio for video. So when it comes to editing audio for video, there's multiple ways to approach the same thing. There are some folks that feel that if you're going to do anything with audio, it should be done in Pro Tools, because Pro Tools is an industry standard, not the industry standard, but an industry standard, and it has Pro in the name, so why wouldn't you use Pro Tools for everything? Other folks feel that if you are working in the Adobe universe, you might as well use something like Adobe Audition. Adobe Audition is a dedicated audio application, and it's very good at what it does. Now, there's nothing wrong with using Pro Tools or Audition, but for most of the projects that I work on, both of those workflows are a bit of a waste of time because the audio tools that come with the video editing apps are perfectly capable of handling most of the projects that I do and probably you do as well. Almost every video that I edit can be mixed and mastered inside of Premiere. Premiere's got all the basic tools for mix automation. I can set up subgroups. I can use effects on individual clips. I can use effects in the audio track mixer. I can use effects on the mix bus or master bus. These are the same operations that I would do in Audition or a more advanced audio application. Because I can do so much in Premiere for most of my projects, there isn't really any benefit to me using something else. So the first prong of my three-prong approach is just to do everything inside of Premiere Pro. And you could take the same approach with just about any Pro video app, so Final Cut Pro, DaVinci Resolve, because all of those have similar or better audio capabilities compared to Premiere. The second prong of my three-prong approach is to use Audition when required. Audition can be used as a waveform editor or a multi-track mixer. Waveform editing is more of a surgical editing process where you work on a single file, and that's mostly how I use Audition. I can do spectral editing, advanced denoising, and it's much easier for me to navigate around an audio file to fix things like clicks or pops or heal sections of the audio. Those are operations that you cannot do in something like Premiere Pro and almost any other video editing application. The third prong of my three-prong approach is to use Reaper. Reaper is a digital audio application for computers, offering a full multi-track audio and MIDI recording, editing, processing, mixing, and mastering toolset. It's kind of like Pro Tools, but better. I use Reaper for music composition and recording, but in the realm of audio for video, I use Reaper for advanced mixing and processing. These are projects that usually have an element of sound design in them, and when I do sound design, it involves using many sound effects, layering sounds together with other sounds and effects. I also use Reaper for more simple dialogue and music mixing, but more in an advanced way. Mixing dialogue against music is really not that hard to do, but there are some processes that I like to do that are simply not possible in Premiere or Audition or any other video app as far as I know. Things like sidechain compression, sidechain dynamic equalization, as well as using Reaper's virtual instrument capability to create transitions between music tracks. Now, I'm going to give you a demo of a project that I mixed in Reaper at the end of this course. I want to say again that the things that I'm going to show you in this course are my workflow, and they work for me, but they might not work for you. And there's not necessarily a right or a wrong way to edit and mix audio as long as your end result sounds good. If your project sounds good, you're doing a great job. But as we dive deeper, just know that the things that I'm going to show you work for me, and you can kind of pick them up a la carte. If you see something that works for you, great. If it doesn't work for you, that's fine. It doesn't mean that you're doing it wrong. It's just a different way to do it. Now, coming up next, you're going to learn about the audio processing order in Premiere. In this lesson, you are going to learn about the audio processing order in Premiere. In every project that you edit that contains audio and video, you put audio in your timeline, and then at some point you export your project, your audio and your video get rendered, and then a file is encoded. So in this lesson, you are going to learn the various processes the audio goes through to get from here to your final file. In Premiere, the very first thing that is processed for audio is any gain changes that you have made to your clips. And like you learned in a previous lesson, gain in this case is just increasing or decreasing the digital amplitude of this file. And in Premiere, you can do that by right-clicking on your clips, coming up here to Audio Gain, and selecting that, or you can use the keyboard shortcut G, and that'll bring up the Audio Gain command window. And there are a few options here. I'm not going to go into what each of these does. I'll cover that in an upcoming lesson. But essentially, all of these change the gain, they increase or decrease the amplitude of your clip. And that's the first thing that is processed. After the audio gain, the next thing that is processed is your clip's volume level. So you've probably noticed before that in every one of your audio clips, there is a line that goes down almost the middle of the clip. And if you hover your mouse over it, that says the time code, and then it says volume level in decibels. By default, this will be 0 decibels, but you can click and drag this up or down to decrease or increase the volume of your clip. You can also use a mouse modifier. On the PC, it's Control click. On the Mac, it's Command click. And you can click and create keyframes. And then what you can do is animate, or as they say in the audio world, you can automate the volume over time. So this means that the audio will come down and then go back up as this clip plays back. And this clip volume control, or any keyframes that you have put on, or any simple adjustments that you have made to the volume, gets processed after the gain. So gain, clip volume, and then any clip effects that you've put on your audio. So just like video effects, in Premiere you can also apply effects directly to audio clips. You can do that by coming over here to the Effects panel, and there's a section called Audio Effects. If I come down here and grab something like a parametric equalizer and pop that on this clip, you'll see it show up here in Effect Controls. If I click Edit and then I play this clip back, what you will see is the audio drops down here out of the EQ because the EQ is processed after the clip volume level. Check it out.
I could see was just massive ocean, and I could see the white caps of the waves.
The audio dropped out of the EQ because this is processed after your clip's volume level. So after the clip effects, the audio is processed by the audio track mixer, which is right here. Now, if you don't have the audio track mixer, you can come up here to Window, and then it's right here, Audio Track Mixer. So the audio track mixer looks like a real-world analog mixer or even a digital mixer, and it works in a very similar way. You can insert effects, you can send your audio to another channel via these send assignment slots right here. You have pan controls, so you can route your audio more to the left or more to the right. This is pan balance. You can set your automation mode. You can mute, solo, or enable your track for recording. And then finally, you can adjust your track's volume. Now, I'm not going to go into a ton of detail about every feature in the audio track mixer, but I want to point out this one thing. Audio is processed from the top to the bottom, and that most critically affects the order of your effects. So up here, you can insert up to 5 different effects for audio track 1. That means anything you put on audio track 1, dialogue, music, whatever, will be processed by these audio effects. And the order of the effects matters. If you put some effects before other effects, that will change how the effects sound and how they react. There are some effects that control things like equalization, some effects that add reverb, some effects that control the dynamic range or the amplitude of your track, and the order does matter. Again, you're going to learn more about effects and the effects order that I think work pretty well for dialogue and music tracks in an upcoming lesson. But for now, I just want to leave you with this. A way that you can kind of visualize this is the audio comes in at the top and then it's processed from the top to the bottom. That's not actually what is happening because there's no circuitry involved here and the audio is not flowing on wires or anything, but that's how I like to think about it, and I think that'll be pretty handy for you to think about it as well. So the very last thing that is processed by the audio track mixer in audio track 1 is the volume control, which is down here, and you can adjust that on the fader, or you can click and drag this right here. After the audio goes through audio track 1, it is routed to your mix track, which is right here on the right side. And this will move further over to the right the more audio tracks that you have. The mix track is where all of your audio goes, no matter how many audio tracks that you have. And just like audio track number 1, there are also effects that you can put on your mix track. And I'm going to cover that in an upcoming lesson as well. Mix track effects or master track or master bus effects are really important to control and monitor your video's loudness and the overall sound of your project. And just like in this track, the effects order does matter here, and the audio is processed from top to bottom, which means audio effect number 1 is processed first, second, third, fourth, fifth. Finally, you can set the volume control for your mix track right down here. And this is the very last thing that gets processed by the audio track mixer. Now, technically, your audio can go through one more stage of processing, and that is in the export settings. There is a tab right down here called Effects, and there are some video things that you can do here. But if you scroll down, there is a section that says Loudness Normalization. And this, if it's enabled, is the very last thing that gets processed. But that pretty much does it for the audio processing order in Premiere. Really quick to review. The first thing that's processed is the audio gain. After that, it's your clip's volume level, then any clip effects that you've applied. After that, it goes into the audio track mixer and it's processed from top to bottom on track number 1, including any effects or any sends that you've set up. And then it goes to the mix track and it's processed again You can think about it from top to bottom. So these effects are all processed in order. And then you can set the volume for your mix track right here. Now, that may seem like a lot of things that you have to keep track of, but for a lot of projects that I do, I don't ever need to change any of the track volume levels or the mix track levels. I mainly focus on getting my gain right, my clip volume level right, putting some of my favorite effects over here in audio track number 1 for dialogue, and then whatever I'm doing over here for the other tracks, and then a few effects over here for the mix track, and that's it. I don't usually do any volume automation or even change the volume of any of the tracks most of the time. So even though there are a lot of things that you can do to process your audio, it doesn't mean that you have to use all of them or any of them in every project. But I wanted you to understand the order that the audio is processed in Premiere. Well, that's it for this lesson. Coming up next, you're going to learn how to level your clips in Premiere. In this lesson, you are going to learn how to sync audio to video. Syncing audio to video or synchronizing audio to video is something that is super common in editing. Sometimes you get footage to edit that has the microphones used in the production, so shotguns, lavaliers, maybe a handheld microphone, that are wired directly to the camera, and then when you pull your footage in, it sounds great and nothing needs to be synchronized. Other times, like in this example of my friend Josh here, the audio and the video have been recorded on separate devices. So the camera that was used to record this does have audio, but it's using the onboard camera microphones, and it doesn't sound so great. And the microphone that was used for the production was wired to an external recorder. And what I need to do is sync those up. So in this example, I'm going to show you a really simple way to do it using the audio. So if I play the audio back here in this clip,
and it was hot and it was tiring.
So you can hear Josh's voice, but it sounds like the microphone is 10 feet away. And like I said, that's because the microphone is 10 or 12 feet away on the camera using the camera's onboard microphone. And the good audio, the production audio, is over here in my assets folder under audio. I'm going to bring that out. And when I bring that out, it's not going to be in sync.
Time that I had really experienced doing something.
So the easiest way to synchronize these in Premiere is I'm going to select both clips, right-click on them, come up here to synchronize, and in this window I have a few options. I can use the clip's start point, the clip's end point. I can use timecode if I was using an external timecode synchronization device. I can use clip markers if I used a marker at the same audio event in each one of these clips. In this video clip and this audio clip, I could use that clip marker to synchronize. But what I'm going to do, and probably what you're going to do 9 times out of 10, is use the audio in both clips to try and synchronize. I'm going to press OK, and Premiere is going to get to work processing these clips. And let's see how close Premiere got.
Really bigger than myself, serving this community.
That sounds pretty good to me. It doesn't sound audibly delayed. I can't tell that there's any synchronization issues when both of these are playing at the same time. Usually that's the best way to hear if your audio is in sync, is to play your production audio against the camera's audio. Because even if it's off a very little bit, it's pretty easy to hear. And this sounds like it's very much in sync. Now, this is not always the case because sometimes your video clip here with the onboard camera microphones or whatever microphone is being used to record that scratch audio that's just supposed to be used for reference or syncing is far enough away or has too much noise on it so that Premiere cannot synchronize it very well, and you may need to go and do it manually. Now, usually what I'll do, and what I did do in this case, is right after I press record on both devices, I'll just clap from behind the camera to give me a failsafe. If for whatever reason Premiere does not do a good job syncing these, I have a big spiky waveform at the beginning of each recording that I can go in and use to synchronize myself. And I'm going to show you that because I'm going to show you how to get this audio super precisely in sync with this video using that clap sync at the very beginning. So if I zoom in right here in the very beginning, right now, this is the most I can zoom in with this view. You can see that they are pretty close. Here's the clap in the camera. Here's the clap from the shotgun microphone that was positioned right here. But they're not as close as they could be. And I don't mean that they should be perfectly aligned, because that would actually be incorrect. I used to do it this way, but I came to the realization that aligning these perfectly is not technically correct. Because if you think about the physics going on in this situation, the microphone is maybe 10 feet away from the camera. It's positioned right here, just off frame, and let's say it's 10 feet away from the camera. And if I clapped from behind the camera, that 10 feet equates to about 13 milliseconds of time. So these two claps should actually be 13 milliseconds apart. So after this one, 13 milliseconds later, I should have this clap right here. Now, do you need to do this? No, you don't, but I want to show you how to do it, just in case you're one of those people like me who wants to get it perfect. And to do that, what I do is I come up here to this little menu for the sequence, the little hamburger menu or sandwich menu if you prefer. And I click the flyout and I choose Show Audio Time Units. Now, by default, I believe this will show you hours, minutes, seconds, and samples. Samples is referring to the number of samples in the recording, which is 48,000 times per second. And for this operation that I'm going to do, that's useless. What I want is milliseconds, and I can get that by control clicking or command clicking on the Mac. And now I have hours, minutes, seconds, milliseconds. So what I can do now that this is switched over to audio time units is zoom in to see the actual waves here, and I can zoom in to an absurd level. But what I want to do is I want to come right here to the very beginning of this clap, and I'm going to select my video clip, and I'm going to hit M on the keyboard to drop a marker. That's right at the time code of 2 seconds and 466 milliseconds. And I know from what I just said, I want that second clap to show up 13 milliseconds later. So if I add 13 milliseconds to this, that'll be 79, which is right here. I'm going to drop another marker here on this video clip, and then I'm going to slide over this audio clip to the left. Now, right now, it's not going to slide over to the left because it's butting up against the beginning of the sequence. But if I hit C and grab the razor tool, switch back to the selection tool with V, and just delete the beginning of this, now I can slide this over, and I can get it pretty darn close. That's close enough right there. And now this is perfectly in sync. It was really only about 7 or 8 or 9 or 10 milliseconds off. And is that going to make a difference? No, it won't. But now you know how to do it perfectly. From here, what I would do is just clean my sequence up a little bit. I'll trim out my audio to get it right to the beginning of the video here. Very good. I'll do the same for the end. I'll just trim this back right here. Sometimes I like to zoom in because occasionally Premiere will refuse to snap this to the beginning or the end of the clip. It looks like it's done it correctly here. Then I'll come to the very beginning by hitting home, and I'll zoom in, and I'll just delete this beginning part right here so that it starts right at the beginning of the sequence. Sometimes what I do is just trim out any garbage at the beginning of the clip so I don't have to deal with it, but I'm not going to do that now. And I usually switch back to this frame view here or deselect Show Audio Time Units because that works a little bit better for me for scrubbing and going back and forth and looking at each frame if I need to. There's one more thing I'm going to show you that has to do with audio-video synchronization, but that's coming up in an upcoming lesson where you learn how to fix audio drift. Coming up next, you're going to learn how to level your clips in Premiere. In this lesson, you will learn how to level your clips in Premiere. Picking up from the last lesson, I'm going to show you how to level your clips in Premiere. Now, by leveling, what I'm referring to is adjusting, well, the audio level, the audio amplitude, the audio volume. Sometimes it's called different things, but that's what we're talking about. And the reason why you need to do that is sometimes the clips don't come in at an optimal level. Some folks record peaks at -18, -12, -6 decibels. And when you're editing, it's nice to get those clips to kind of a nominal or average level for all of your projects. It makes it easier to listen to so that you don't have to turn up your playback device, and it makes all of the processing that you're going to do later a lot more consistent. So I'm going to show you my normal process for leveling clips in Premiere. To start, what I would do is unlink this video from this audio with the keyboard shortcut Control-L, and then I'll select my video and audio and link those together. I like to have my dialogue on audio track number 1. And then from here, what I do is I go up to Window and bring up the Essential Sound Panel. The Essential Sound Panel is a collection of tools that will help you process things like dialogue, music, sound effects, and ambience. It's my opinion that most of the tools in here are not that useful. At least they're not that useful for me. But there are a few very genuinely useful tools that will save you time. And one of those is auto-matching loudness. And I'm going to show you that right now. So because this is a talking clip, what I'm going to do is select this and then assign it a tag by clicking this dialogue button right here. And now I'm presented with a bunch of tools that I can use to process dialogue. But like I said before, the only thing that I really find useful is this loudness auto match. So I'm going to click this button called auto match and watch down here. You can see that it has increased the amplitude of my clip. Now what this function does is it auto matches to a target loudness of -23 LUFS. And I think this is pretty good because, well, for one, you can't change where the target is. So some folks may like their dialogue matched to a loudness of -20, but in Premiere, there's no way to do that because we can't change where this target is. You can in Audition, but I'm fine with this being at -23. And if you look down here in the sequence, if I right-click on this and go to Audio Gain, you can see that it has set the gain to 8.1. So really quickly, I'm going to go over what each one of these processes does in the Audio Gain command window here, because sometimes you may want to tweak it up or down a little bit, and this is the way that you would want to do that. After you've auto-matched, you may feel like, well, it's not exactly where it needs to be, so you may want to increase it or decrease it. And to do that, you would press G on the keyboard or right-click and choose Audio Gain to bring up this window. This first option here allows you to set a specific gain value. Now this works on one clip or multiple clips. Let's say, for example, you had 3 clips. One was set to -2, the other one was set to +2, and the other one was set to -5. If you want to select all of them and then set the gain to a specific amount, maybe you want to just reset everything back to 0, you can do that with this option here. The next option, which usually pops up by default, is Adjust Gain By. This gives you the option to adjust the gain up or down by a certain amount on one clip or multiple clips. So if you had one clip or multiple clips and you just wanted to increase the gain by 2 decibels, you wouldn't need to know what the gain is. You can just use this option here and just input 2 and then press OK, and that's going to turn all of your clips up 2 decibels. That's pretty handy, and most of the time I use these first 2 options. Now, before this Essential Sound Panel was introduced, I used to use Normalize Max Peak to and Normalize All Peaks to. These 2 operations basically do the same thing. I believe that Normalize Max Peak to works on a single clip and Normalize All Peaks to works on multiple clips, but I'm not 100% sure because the Adobe user guide has very confusing language. But either way, this is not a great way to normalize clips because essentially this normalize operation analyzes your clips, finds the loudest single peak, and then sets that to a specific value. And that's essentially useless because you have no idea what the loudest peak is in any audio clip. It could be a sneeze, it could be someone accidentally touching or bumping a microphone, it could be someone making a weird noise. It doesn't matter. It could be anything. And since you don't know what that is, setting that to a specific value doesn't really do much for you. So these 2 options are, in most cases, useless. So just like I said before, what I normally do is I bring in my clips, I select my dialogue, and you can select more than one clip so that you can auto match all of your dialogue, which is super handy. I click auto match, and that's pretty much all I use the Essential Sound panel for in terms of dialogue. If I have to make tweaks up or down, I'll select my clip and hit G and then adjust the gain up or down by whatever I need it to be. Now I'm going to show you another example where this loudness auto match doesn't work. And in this case, it's just with this audio clip here. So this is a clip that I recorded recently of Dr. Tom Campbell talking about nutrition and cancer studies. And what I've done is I have modified this clip in post-production. So I've edited this clip to simulate what would happen if mistakes were made in the recording of this audio. Let's say, for example, someone accidentally turned the gain down, or maybe the lavalier microphone got adjusted or the shotgun microphone got bumped so it was out of position. So you can see in the beginning of this clip here, the audio looks like it's at a pretty good level. You don't see anything hitting the top, which would indicate that it was possibly clipping, but it looks like it's at a pretty good level. But there are definitely sections here that are far too low. And if we play those sections back,
It's one that gets a lot of attention, and there's no doubt that nutrition can play a significant role.
you can hear that Tom's voice is really quite low. In this section here, the waves are bigger, and so I would expect Tom's voice to be at a relatively good level.
In Ornish and Dr. Caldwell Esselstyn Jr.
And it does sound that way. And at the very end, it sounds like it's really low again.
back in 1980, a major
And sometimes you get clips that are like this. Maybe someone left the recording on for a very long time and there were some adjustments or mistakes made. Someone was closer to the mic, someone was further away. The gains were set maybe not properly. And you end up with a clip like this. How do you deal with normalizing the loudness in a clip like this? Well, let's see what happens if I come up here and I click Auto Match. Now, I have previously assigned this a dialog tag. Okay, that says it's auto matched this to a target loudness of negative 23 LUFS, but you can see just by looking at it, it's actually done very little. You can also see by hovering over it, it says the gain has been set to +2, and that's not going to work. So instead, what I'm going to do, and probably what you should do most of the time, if you're going to stick to Premiere for fixing this, is I'm going to split this with the keyboard shortcut Control-K. That's going to add an edit point. And I'm going to split this right between these audio blobs here. So this is Tom talking, and I can tell from experience, this is a breath between this phrase and this phrase. So I can split it in between here, and that will be more or less fine. And I'm going to split it right here, and that should be good. Now when I select all of these clips and I hit Auto Match, now the Essential Sound panel is going to treat each one of these as an individual item and is going to auto match the loudness for each one. And this is going to be a lot more consistent. You can hear in the first clip,
the greatest causes of death and disability worldwide.
the second clip,
Take a look at a few examples to see how nutrition fits in.
you can hear there's a problem, but at least I have Tom's voice up to an appropriate level. The problem is that because I brought Tom's voice up a lot, and if I hover over, you can see it's been brought up 19.7 decibels. The noise has also been brought up 19.7 decibels, which is something you have to watch out for. The third little clip here
80% of all cardiovascular events.
sounds pretty good to me. And the last clip,
All the way back in 1980, a major report suggested that anywhere from
again, Tom's voice has been brought up to an appropriate level, but so has the noise, and that's something that you're going to have to deal with. You can see the gain has been increased by 26.6 decibels, which, depending on the noise level of the recorder and the audio hardware, is a lot. If it was a super clean recording, sometimes you can get away and there won't be this much noise. I should tell you that I intentionally added noise to this clip to show you what it would be like in kind of a worst case scenario, because if I just adjusted the levels as it was recorded, the noise really wouldn't be that bad. So I intentionally added back a little bit of noise when I edited this for this example. Again, this would be a worst case example. And what you'd have to do from here is treat this clip and this clip right here separately with denoising operations to get them clean enough to match these two clips right here. That's not a big deal. It's just one little thing that you have to consider. But for audio clips that were cleaner and had levels that were all over the place, this is how you would deal with it. You can split it up into individual pieces, and then you can auto-match it, and things should be pretty good. In an upcoming lesson, you are going to learn how to use audio denoising to clean up problematic clips in both Audition and Premiere, and that'll help you deal with problematic clips like this with excessive noise. For now, check out the next lesson, where you are going to learn how to do some basic audio leveling and processing in Audition. In this lesson, you will learn how to level your clips in Audition. Like I mentioned in a previous lesson, I do most of my audio processing and audio editing inside of Premiere, and I only go to Audition when I actually need to. And this is one of those cases. So you're looking at a project that I shot in my studio. This is Dr. Tom Campbell and his father, Dr. Colin Campbell, and they're talking about a book that they co-wrote 20 years ago called The China Study. This was recorded with 2 cameras, and the audio was recorded on a separate audio recorder, the Tascam DR100. So I have a lavalier on Tom here and another lav on Colin. In the audio, I brought into Premiere and I synced it up so that you could hear what was going on. But the issue, and the reason why I need to send this over to Audition, is because a stereo audio recorder records a right and a left channel. So Tom's mic is on the left and Colin's mic is on the right. I'll solo audio track number 2 so that you can hear. This should be Colin talking right here.
All those diseases were more or less in the same geographic areas.
And you can see that's mostly on the right channel here. And then this section right here, I can see that this is where Tom is talking.
The idea is the breadth of evidence. So beyond.
And the level is a little bit lower because Tom is, his microphone is a little bit lower because he's looking away from his mic, and it's mounted just a little bit lower than Colin's here. And so there are a number of issues that make me want to process this in Audition rather than Premiere. Even though there are tools in Premiere that I could and have used to deal with clips like this, I'm going to show you how to do it in Audition. So what I'm going to do, rather than right-clicking on this file and choosing Edit Clip in Adobe Audition, is I'm just going to go and grab the file on the hard drive and open that up in Audition. And the reason is, if I choose this option right here, Premiere is going to render and replace this audio clip, and that's just going to create another duplicate file that I don't need at all. And because this audio clip is almost an hour long, that's going to be almost a gigabyte in size. So instead, I'm just going to right-click over here in the project panel and come up here to Reveal in Explorer. It's right off screen here, and I'll just drag this down to Audition and open it up. I'll double-click to open it in the Wave Editor and play it just to verify that I have the right file.
We survey a large
Yep, that sounds right to me. And now I can right-click on this file and choose Extract Channels to Mono Files. That's going to take just a few seconds because this is a pretty long audio file. So here are my 2 files. I have the left channel here, and this should be Tom speaking.
Welcome to the China Study 20 years later.
It's pretty low, but because this is a 24-bit audio file, that should not be a problem to recover. And then here is Colin speaking right here.
superb writing skills.
Perfect. Now, from this point, I could just export both of these files, bring them back in Premiere, and process them the way I normally do. However, because they're already in Audition, I'm going to take advantage of some of Audition's tools to process these a little bit further. And one of those is using this Match Loudness panel right here. So just like in Premiere, Audition has the ability to analyze the clip's loudness level and do some loudness matching for me, which is very handy. So if I bring down the clip of Colin here, which is the right channel, and I run this loudness match, by default, this is usually set to -23, just like it is in Premiere. But what I want to do is set this a little bit lower than -23, and here's why. Because this clip has a lot of gaps in between where Colin is actually speaking, the match loudness is going to take all of that into account to try and calculate this file's overall loudness level. And if I did set this to -23 and run this, I want to show you what's going to happen. Okay, so if I come up here to the amplitude statistics panel, which, by the way, if you don't have any of these panels up, you can just come up here to Window, and you can see amplitude statistics is right here, and match loudness is right down there. So that's how you can access both of those. And I'll just scan this for amplitude statistics, and it'll spit out a bunch of values here. But the main thing that I wanted to look at is the loudness for the track. In Perfect, it's -23. The problem is, if I scan a section that's just Colin talking, which is, let's say, right here, and I scan this, it's actually going to be a little bit louder than -23, -21.35, which is totally fine. That level of loudness is totally fine. And a couple of decibels plus or minus is not going to make a big deal if I exported this and brought it back into Premiere. However, the way that this particular loudness matching works is it runs the audio through a limiter. And what that means is that the louder bits of audio, you can see right here and right here, they don't go above -1. So those bits of the audio, and there are maybe a dozen more throughout this file, have hit this limiter. And I don't know what that sounds like. Now, in reality, it probably sounds fine, and I shouldn't be fussing about this. But what I prefer to do is to not hit this limiter so hard. And if I can get this to be -23, where just Colin is talking, and have it not hit the limiter, that's what I would prefer to do. So what I'm going to do is undo that, and I'm going to set this target loudness just a little bit lower, -25. And I'll run this again. And now this is going to make the overall loudness hit -25, which should mean that the parts where Colin is actually speaking are right at -23. And that was just a guess. This is looking good. I see just a handful of audio peaks here that are actually hitting the limiter. And if I come to this section right here and scan it again, I'm guessing this is going to be, hey, look at that, -23.3. Perfect. What this means to me is that this is going to sound basically exactly the same as how I run loudness auto matching inside of Premiere, and it hasn't really done anything with this limiter that is going to bother me, meaning that the audio has not been pushed up into this limiter, which can sometimes sound a little bit funny. In this particular case, I don't think it would have mattered either way, but I'm just showing you how I prefer to do it. So this is pretty much set in terms of loudness. Anywhere that I scan in here where Colin is speaking should be more or less right at -23. In fact, I think I grabbed just a little bit where he wasn't speaking. So if I scan this, -24, totally fine. It's within a margin of error. So now what I'm going to do is I'll do the same thing to the other clip. So I'm going to delete that out of the match loudness panel there and pull in Tom's clip. I'll double click to open that up here. And if I just take a look at this file, I can see that there's a lot more space in between the actual talking. So I'm thinking that I could probably set this down to -26, and that should get me a little bit closer on Tom's loudness. That looks pretty good. I don't see a lot of peaks that are hitting the limiter, nothing that I'm really concerned about anyway. And if I scan a section that I know is just Tom talking here, let's see where that hits. -22.6, so that's totally fine. It's basically -23. Let me scan another section here just to verify that. Perfect, -23.2. So now what I have are two files that are basically the same loudness, but only when the people are actually speaking. So the loudness of this entire clip is at -26, but I don't care about that. The only thing that I care about are the parts where they're actually talking. So in terms of loudness matching, there's nothing else that I need to do. However, while these clips are in Audition, I'm going to take the opportunity to do a little bit of denoising while the clip is in Audition. And you're going to learn about that coming up in the next lesson. In this lesson, you're going to learn how to do some basic denoising in Audition. So I'm picking up right where I left off in the last lesson. I took my stereo wave file here and I split it into two mono files, and I did some loudness matching to bring them up to the appropriate levels of loudness, but only when they are actually speaking. But while the clips are in Audition, what I'm going to do is take the opportunity to do a little bit of denoising. Now, there are some denoising tools in Audition that are not available in Premiere. If you look in the effects rack here, underneath Noise Reduction and Restoration, there are a few effects that are the same. One of those is denoise. There's also an effect called Adaptive Noise Reduction, which I don't think is very good, and Automatic Phase Correction, which is not something that I need to use in this example. So there are a few different options there. There's also an option up here under Effects and Noise Reduction called Noise Reduction Process. And you can bring that up with the keyboard shortcut Control-Shift-P. Now, this method of noise reduction has been around for a long time, and it's pretty effective if the noise in the background is really consistent. And in this case, I know that it is. So the idea here is you want to scan a section of noise, or you want to capture a noise print. So I want to find a section here that is quiet and no one is making noise. And unfortunately, I did not think to record a bit of silence in this. Actually, there might be some right here that'll work. Let's see. Oh, that is really quiet. I can barely even hear it. Okay, so I'm just going to scan this section right here. I'll select that, and then I'll choose Capture Noise Print. Okay, so here is the noise. And I don't need to do a lot of noise reduction. In fact, it's going to be so subtle in this case, I'm not even sure you're going to be able to hear it, but I'm going to do it anyway. Now that my noise print has been captured, what I can do is play the file from within this effect, and it's going to preview what the effect is doing.
Welcome to the China study 20 years later.
If I toggle this power button here off, you'll hear this same section without the noise reduction being applied.
Welcome to the China study 20 years later.
And with it being applied.
Welcome to the China study 20 years later. That is 20 years.
I admit it's pretty darn subtle, but I'm going to run it anyway, and I'm going to leave it at the default values, which I think are 50% and maybe 12 decibels. Let's just do 10 decibels. I don't want to get too heavy-handed with this. I almost never run this at 100% because it does sound kind of artifacty, and I can probably go like maybe 6 or 8 decibels. Yeah, let's try something like maybe 8 decibels. And what this is going to do is it's going to remove about 8 decibels of noise from this whole file. And I'll just select the entire clip and click Apply. This will take a couple of seconds because this is a very long file. But what you'll see is that the noise floor, which is the very quietest thing in here, will get smaller. It's kind of hard to see right now, but I'll make sure that I zoom in so that you can see the difference before and after. Okay, so let me undo that, and then I'll redo that, and what you'll see is this very faint line there gets, well, it gets even fainter. And that's the noise level in the background, or the noise floor, that has been removed. Now, I want to make sure that that noise reduction has been processed in a very clean and transparent way, such that I can't actually hear what it's doing. If I play this back and I hear all kinds of chirpy background artifacts, I'll know that I've way overdone it. Now, in this case, I think that's impossible because there was hardly any noise to begin with. But let's check it out.
Welcome to the China study 20 years later. That is 20 years from when we started writing the book. These are questions that we have received that reflect a lot of what we hear from people.
Okay, that sounds totally fine to me. I actually had to turn my headphones up quite a bit just to be able to hear what it's doing. I can still hear some background noise on there, but that's totally fine. I'm not going to worry about that at all. Let me take a look at Colin's mic over here. This was actually recorded with a wireless microphone, so it's possible that there is a touch more noise. I don't really think so. But let's check it out. So this is just a section of noise right here. I'm going to play it to make sure there's no other background things happening, like someone breathing. I don't want to capture a noise print that has like people rustling around or breath noises in it. I want to make sure that it's just background noise. Good. In fact, I can just dial that in a little bit more. So that's just the background noise. Again, this is super low, and I would not at all be normally worried about this. So I'm going to do the same thing. This time I'll use the keyboard shortcut Control-Shift-P, and I'll capture this noise print, which is going to be a little bit different, even though the clip was recorded in the same location, just feet away from the other microphone. It's a different microphone capsule, and it's being run through a transmitter and receiver, so it's not going to be exactly the same. So my noise print is captured. Let me go to a spot here where Colin is actually speaking, and I'm going to play it just to verify that this level of noise reduction is not going to be too aggressive.
Well, as you said, the China Study is the name of the book, and the book was co-authored.
Now, that sounds totally fine, but let me see if I can make this sound way too aggressive so that you can hear what that sounds like.
Two of us, with your superb writing skills, by the way, I should say. But in any case, the China Study was named after the project itself.
Actually, I don't think I can in this particular case. What I'd have to do is artificially inflate this noise, which, I tell you what, I'll do just for you. So I'm just going to make a little selection here and increase the gain up a lot. And then I'll use this Control-Shift-P for my noise print, which is going to be ridiculously high. And if I disable this, you'll be able to hear that. Now, if I try to remove that much noise from Colin speaking when it's not even there, I mean, I'm kind of artificially showing you what's going to happen if you set this too aggressively, because I want you to be able to hear it so that you can identify it and then back it off just a little bit.
Well, as you said, the China Study is the name of the book, and the book was co-authored by the two of us.
So you hear that kind of underwater, warbly, kind of chirpy sound? That is noise reduction that is being run way too aggressively. And again, I did this just for a demonstration so that you could hear it, because sometimes when I post-process this and it gets put on YouTube and you're listening to this on whatever playback device, subtle noise reduction is not always easy to hear. I mean, if I were to remove the actual level of noise in this, you're going to say, okay, it sounded exactly the same. I don't even know what you did. Well, what is the point of this lesson? So I wanted to make sure that I at least showed you what hyper-aggressive noise reduction sounds like, and it sounds like what you just heard. But I just grabbed another little section. I'm going to set this up super conservatively and just run it. You're probably not going to even be able to hear the difference, but that's actually a good thing. That means that it was recorded in a pretty quiet environment, which we can't always control, and the equipment being used was also fairly good quality, so it wasn't generating a lot of self-noise. And I'll just play a little bit of Colin speaking so that you can hear that it wasn't too aggressive.
Well, first off, because of the way the population existed at that time, rural China, as I said, they didn't eat much in the way of animal food.
There you go. This has been denoised. Again, this is a real basic sort of denoising operation. Now, I typically only do this style of noise reduction, which is what they call a noise reduction process, when the level of noise is really, really low. When the background noise is a little bit louder, even this method of noise reduction, I don't think works that great. And typically what I do in those instances is I use this effect called denoise. This is more of an adaptive noise reduction, even though this one says adaptive noise reduction. This is terrible. This noise algorithm is very, very good, and I think it works much better on clips where there is a higher level of ambient noise. But I wouldn't use it on this clip here because the background noise is too low, and I think that the denoise effect here, this one that's actually called denoise, is even too aggressive for a clip like this. So I prefer to use the noise reduction process that you just saw there. So at this point, I feel like this is good to go. I could further process this in Audition. I could add my EQ, my compression, and all of the other processing that I would do for dialogue tracks, but I'm not going to do that. I'm going to do that in Premiere like I normally do. So at this point in the process, what I would do is export both of these files. I'll hit Control-Shift-E and I'll name this Colin. And I want to make sure that's going to the right spot. I think that is correct. And then I'll double click on the left file, hit Control-Shift-E, and I'll name this Tom. And there we go. That's been exported. Well, that about does it for this lesson. Coming up in the next lesson, you're going to learn how to do some targeted noise reduction in Audition. In this lesson, you're going to learn how to do some targeted denoising. So in the last lesson, I demonstrated how to do some kind of broadband denoising, where I selected a bit that was only noise in a recording and then applied a noise reduction process to the entire clip. What I'm talking about doing in this lesson is finding very small sections of noise that you want to remove. Squeaks, pops, clicks, things of that nature. Now, if I'm honest, getting rid of these can be pretty tedious, and sometimes it can be impossible and you just have to deal with it. But there are some things that you can do, and that's what I want to show you here. So in this first example, I'm picking up where I left off in the last lesson. This is Tom talking again, and I found a little click or pop noise in the background, and I want to show you how I would attempt to remove it. Check it out.
Welcome to the China study 20 years later.
Okay, it was right here. Welcome to the China study. And then I believe this is 20, and then there's a click sound right in here somewhere.
20 years.
Did you hear it? I'll play it one more time for you.
20 years.
So this is the word years. This is 20, and this is the word T. So I know that it's somewhere in here. So part of the battle, if you will, in getting rid of these noises is actually finding them. And sometimes they can be pretty tricky to find. But if I zoom in to this area, actually I put my cursor right on it, which is just dumb luck. What you have is we have a lower frequency thing, and then the click or the pop is usually a tighter grouping of waves because it's a higher frequency thing. And so that's going to be your visual cue for where to try and remove that noise. This section right here, this is the noise. The problem is I don't know exactly where it ends. I'm going to start by trying to remove this right here. And Audition's got some really clever ways of going about removing this. One of those is with an effect called Auto Heal. You can find that up here in the menu or with the keyboard shortcut Control-U. So if I make a little selection here, now I'm just going to drop a marker as well. So I know where this section is. I'll hit Control-U, and you can see, I'll undo that and redo that. You can see that little bit of noise, it just goes away, which is pretty cool. But let's see if that actually removed it fully.
20 years.
Ooh.
20 years.
Actually, I'd say they got about 50% of it. So there's something that's remaining. The trouble is it's a little bit lower in frequency, and I don't know exactly where it is. It looks to me like it might be here. So the next thing that I would do is try and just heal the section right next to it, and maybe even this part right here. I don't know. I don't want to auto heal too much, because if I took this whole word and did an auto heal, you're definitely going to hear that.
20 years.
Did you catch that? Let me back it up one more time.
Study 20 years.
Yeah, that's not great. So let me undo that. But let's see if those other two little heal operations fixed it.
Study 20 years.
No, they did not. So let me undo once. So it's not in this section fully because I heard it kind of, well, here's the thing. I don't know where this is exactly. I know that it's somewhere here. Maybe I'll just grab a bigger selection and just heal this. And that might have done it. Let's see.
Study 20 years.
Ooh, I think that actually worked. So this auto heal effect is pretty awesome when it works. It works best on very, very short or very targeted, very small sections. The bigger the selection, the more chance you have of completely ruining whatever it is that you have selected. But that right there, I think did enough noise reduction or enough healing to remove it. I mean, I don't even really hear it.
China study 20 years later.
I think that's pretty good. So that's one way to go about doing this. There is another way to look at your audio inside of Audition, and that is with the spectral frequency display. Now you can get to that a number of ways. You can come up here to View and then clicking on Show Spectral Frequency Display. You can use the keyboard shortcut Shift-D, or you can just click this little handle down here and pull up this, I don't know what this thing is called. It looks like a window shade, but you can just pull this little bar up and now you can get a look at the spectral frequency display. And so this is pretty neat looking, but what this is showing you is the audio spectrum. So you have, well, it goes down below human hearing. So you see like 4 hertz way down here at the very bottom, and then all the way at the top, it goes up to 20 kilohertz. And these little blobs here represent areas of more and less intensity. So the brighter areas are going to be areas with more energy in that frequency range, and the darker areas have less energy, and black has basically no energy, but there are very few sections that are completely black. The other things that are in the background is basically background noise. And so what you're looking at here when Tom is speaking is you can see that the lowest kind of blobs in this spectral frequency display are the fundamental pitch of his voice, which is right around 100 hertz. And all of these other lines above this, these are all harmonics that make the human voice sound like the human voice and not like an oboe. If the harmonics had a different intensity, it would sound like something else, but this is what they look like for the human voice. These are the areas that you don't want to affect when you are doing these healing operations. And you can search for noises in the spectral frequency display and use various selection tools like the time selection, the marquee selection, the lasso selection tool, or the paintbrush tool to select areas in here. And you can kind of solo those by hitting the space bar. And you will hear kind of what that sounds like. If you want to try and identify a particular noise, although I don't know why it doesn't allow you to play very much before and after that, it is kind of difficult to hear if you were just to make a very small selection. It's not always easy to identify the noisy thing in there kind of out of context, but when you identify a noise, you can make a selection and then you can try and use the auto heal selection effect, or you can just grab this little amplitude adjustment and you can turn down the volume of your selection, which is another way that you can go about removing noise. I want to show you another example here, and this is in Colin's clip. Let me switch back to the waveform display here. And Colin was sitting on a director's chair, and that director's chair was, well, squeaky. It's a little distracting, and I attempted to remove some of it, and I want to show you how that went. Spoiler alert, didn't go very well at all, but I want to show you the process anyway. So here's a little section where you can hear some squeaky chair sounds.
Well, as you said, The China Study is the name of the book. And the book was co-authored by the two of us with your superb writing skills, by the way, I should say. But
you can hear that there are a few sections in here. It's pretty subtle, but you can hear some squeaks in the background.
Well, as you said,
like right in the beginning here. And the problem with these kind of noises, although you'd think you'd be able to identify it and take it out, the problem is that this type of noise overlaps way too much with the frequencies that make human speech sound like human speech. And this type of thing is impossible to remove. If you try and look at what this noise looks like with the spectral display, it doesn't look like much because it's really quiet, but because it's in an upper frequency range, so it's all up here above, I would say, 1 kilohertz. It's in an area that our ears are very sensitive to. So you can hear it, but using these tools, it's very difficult to spot. And you can kind of scroll here and make the section of frequencies that you're looking at a little bit bigger. So I can tell that this first little squeak here is kind of in this range right here, right? That's around, 12 kilohertz. And some of this stuff right here is tricky to remove because if you imagine this sound happening over this right here,
you said the China.
how are you even going to see that? You can't see that at all. So these types of sounds are very difficult to remove. In fact, I'll go to one that's somewhere in this neighborhood.
Authored by the two of us with your superb writing skills, by the way, I should say.
Okay, so here's a squeak right here.
By the way, I should.
Okay, I'm going to switch to the time selection tool.
By the way, I should.
So I think the squeak is right here. I think this little blob here is one component of it, and then there may be some other stuff down here. I don't know. It's very tricky. So the first thing that I would try and do is make a broader selection like this and see if I hear it. Yeah, okay, so it is in there, but I can also hear some of his voice in there. So now it's a game of whack-a-mole because I don't know what frequencies go with what. So essentially what I would do is just guess. Okay, so I would start here and try to auto heal that. Okay, good. That made it darker. I also just could have pulled down the intensity of that selection there. That would have done the same thing.
By the way, I should say.
But that didn't get rid of all of it. So let's see. Is it here? I don't know. Okay, that's part of it. So let me add this selection to it as well. And then I'll heal this. Let's see. Did that get rid of it? I'll drop another marker too so I know where I am. I don't get lost because looking at these blobs is sometimes a little bit disorienting.
By the way, I should say.
Okay, so that did get rid of some of it. But this is what I was talking about before. The squeak is gone, but now part of his voice is gone too.
Skills, by the way, I should say.
Now there's a weird artifact where it sounds like, I don't know, there's definitely some processing happening on this one word.
Skills, by the way, I should say.
So all this to say that, yes, you can do some cool things in Audition. You can do some very targeted noise reduction operations, but it is not magic. Sometimes when you try and remove parts of the frequency spectrum and you try to do some healing or you turn things up or down, you end up removing things that are important to making the thing sound like the thing. So the best way to go about this, and you'll have the most success in trying to remove noises that happen in and around when folks are speaking. So if there was a noise that happened here, you could remove just the noise pretty well and leave kind of the background tone, if you will. It's kind of the background room tone or the ambience more or less intact. But when the noise overlaps someone speaking, it's anyone's guess because it's very difficult to try and find where the noise actually is. And then you have to go about trying to paint out just those frequency bands and not affecting too much of the person speaking, which in my experience is next to impossible. All right, that about does it for this lesson. Coming up in the next lesson, you're going to learn how to fix audio drift. In this lesson, you will learn how to correct for audio drift. So I'm picking up where I left off in a previous lesson. I've imported my 2 clips from Audition, and I'm ready to synchronize them in Premiere. But this gives me a good opportunity to show you how to correct for audio drift. So audio drift is something that can happen when you're using different devices, so a camera and an audio recorder, or it could be mobile phones, it could be footage that you got on the web through services like Riverside.fm or Zoom. And when you're trying to sync audio or video that came from different devices, what you can find is that over the course of a longer period of time, so in this case, it's going to be almost an hour, the audio can tend to seem like one of them is going faster than the other. And that's because it actually is. So the timing circuit in these devices is not 100% perfect. Even though it seems very accurate, and by all accounts it is, between 2 different devices, they can be ever so slightly off a little bit. So that means that when you pull them into your project, if you have very long recordings and you synchronize them with the synchronization tools that are available in Premiere, they may be in sync at one point, but then further down the timeline, they may get off again. So I'm going to show you how to try and correct for that. So I'm going to pull in my 2 clips here of Tom and Colin. And I'm just going to let Adobe try and synchronize these just to get them close. So that was Adobe's attempt to sync, and really I did that just to get it close, because now what I want to do is manually go in and sync the beginning, because I already know that these recordings here, this audio recording and this camera recording, are very slightly off from each other. So what I'm going to do is I'm going to go to the beginning and find where I did a clap sync. So right here, I'm going to just trim up the beginning of my audio clip here. Zoom way in the timeline. In fact, I'll hit tilde to go full screen with my timeline panel. And I'm just going to align these to the camera's audio right here. It does make an annoying sound, so I apologize for that, but I'm going to get it close. Now you'll notice that these two clips here are slightly off. And the reason that they are slightly off from each other, and I don't know if you noticed it or not, but they are actually slightly off, is because the two microphones that I was using, one of them, Tom's microphone, was hardwired, and Colin's microphone was using a wireless system with a digital transmitter and receiver system. And that digital transmitter and receiver system has about 3 milliseconds of latency, which means that all the audio from Colin's microphone is 3 milliseconds behind Tom's microphone. In fact, you can see this if I pull this up in the source monitor. This is the original file from the recorder, and I'm looking at audio time units here, which you can get to in the source monitor by clicking on this little wrench icon here, and the option is right down here. Normally, this just shows you the frame view, so you can't zoom in as much, but you can see here is the clap in Tom's mic, and here's the clap in Colin's mic. And the time code is 7:54. And about 7:51 at the peak. So Colin's microphone is 3 milliseconds behind. That's normally not a big deal, but I want to show you how to get everything all perfectly aligned. So this is looking pretty close here. I'm just looking at this little shape and I'm trying to align that visually. That all looks fine. And then what I want to do is come to the very beginning of my video clip, and I'm just going to trim each one of these and snap it to the beginning of the video file. And the reason is, this is where I want to start the time stretch from the beginning of this file. In fact, it would actually be better if I went right to this clap and stretched it from right here, and that'll be a lot easier to see. So I'm going to select all of my clips and hit Control K, and then delete everything to the left, and I'll just zoom in here to make sure that things are still aligned correctly. All right, all of that looks good. Now what I want to do is jump to the end of the recording, and I want to find some kind of audio event in all three of these files that's easily identifiable and as far to the right as possible to try and resynchronize. And I'm not going to bother with offsetting one of these to account for the distance between the production mics and the camera mics. I'm just going to align everything on top of each other to get it in sync for now. So it looks like right here there's something that I can see. It's got a nice hard start. I don't know what this is. Okay, it's a cough. And you can see that in the camera, the cough happens here, and in the microphones, it happens earlier. Now let's see how much of a big deal that is by going back to the frame view here. So it looks like it's about 1 frame off, which is, I think I'm shooting at 29.97, so that's about 1/30th of a second. And I would guess that if I played the audio here, you might hear just a very slight delay between the camera's audio, which I'll solo, and one of these microphones. Let's see if we can hear that.
There's certainly much more to talk about, but
yeah, you can hear that. So this is clearly audible. I'll play it one more time.
there's certainly much more to talk about, but
Yeah, if I didn't correct for this, it would be problematic at the end of the recording. So here's what I'm going to do to fix it. I'm going to switch back to Show Audio Time Units. I'm going to come to this cough event here, zoom way in. And what I want to do is I want to stretch my audio clips so that they're a little bit longer. Now, that seems like it would be problematic, but the amount that it's going to be stretching is so small that it's not going to make any difference, especially over the course of an hour. It's going to be 0.01% or something like that. It's very, very small. So here's what I do. I'm going to come to the beginning of the cough in the audio recorder files, and I'm going to split the audio file right here at the beginning of the cough. I'm going to hit C on the keyboard, grab the razor tool, and just make 2 little cuts right here, and then delete everything to the right. Then I'm going to select both of these and switch to the Rate Select tool, which is R on the keyboard. And what I want to do is I want to stretch these right to here, just like that. And that's really all there is to it. Now what I can do is just trim up the end of my video clip because I know that I don't need anything after this. It's already at almost the end of the recording, but you can see now these waves are more or less perfectly aligned. I mean, they're off by maybe just a millisecond or so. It's really not a big deal. And anywhere I play now should sound perfectly in sync with the camera's audio. So let me solo up here.
Is I think a little bit of a misdirection, but
The only nutritionist on the panel. And I was sort of thinking that maybe.
Perfect. I'll check at the beginning one more time just to show you. Everything at the very beginning here should still be perfectly in sync. This all looks good. I'll check this little audio event here just to make sure things haven't moved. It looks ever so slightly off a little bit, but it's within it's like 1 millisecond. That's pretty much as good as I can get. So in this case, fixing audio drift was, number 1, necessary because you heard how bad that was at the very end. And if I didn't do anything, you would be able to visually see that the audio was not in sync with the video. I mean, if you can hear that much of delay, you're definitely going to see it. And number 2, this was pretty easy to do because, well, the audio recorder, even though it was off slightly from the camera, was pretty consistent throughout. Sometimes when you get footage from phones, the audio can drift forward and back in a single recording. So you may find that you sync it up at the beginning, and then 10 minutes in, the camera from a phone is now a little bit ahead of the video. But you go 10 minutes down the timeline and it's behind. And this can be incredibly frustrating. So to deal with it in those instances, what I would recommend is splitting it multiple times and then time stretching it ever so slightly to match. I've had to do that with footage that I have gotten from Riverside or Zoom. And usually I'll have to do it maybe 5 or 10 times and then just stretch the file to fit. It's not ideal, but it's the best and easiest way that I found to deal with it. Finally, I can do just a little bit of housekeeping here. I'm just going to delete the space at the beginning of the recording and tidy up the end of my adjustment layer here. And now I'm ready to get to editing, mixing back and forth between these 2 microphones and adding all of my track and mix track processing. Now, I do want to say one more thing about stretching out the audio. If I right-click here and I go to Speed Duration, you'll see that these have been stretched about 0.01%, so 1/100th of a percent, which will change the pitch ever so slightly. Now, there is an option to maintain audio pitch, and if this were closer to like 1% of stretch, I would probably do that, but there's no way that anyone would be able to tell that it was being pitched down by 1/100th of a percent, because that is so small, it's essentially imperceivable. However, if you have to get more aggressive with your time stretching, that may be something that you want to check to maintain the audio pitch. Otherwise, the pitch is going to drop if you have to make it longer, or it's going to increase if you have to make your clips shorter, and that could be distracting. All right, coming up next, you're going to learn about the basic effects chain for voice. In this lesson, you will learn about the basic effects chain for voice. So in this lesson and the next few lessons, you are going to learn what I consider are the essential effects to use for cleaning up and processing dialogue tracks, talking tracks, voice tracks. And these include denoising, equalization, dynamics processing, which is compression and sometimes expansion, and also de-essing, which is technically a dynamics processor. Now, are there other effects that you could use? Absolutely. But these are my go-to effects for processing dialogue tracks. So let's talk about denoising. Denoising is basically what it says. It gets rid of noise. Now, the type of denoising that's available in Premiere is kind of a broadband denoising algorithm or effect, if you will. So it's really good at taking out things like background fan noise or some mic preamplifier noise, things that are pretty consistent. So let's listen to this clip and find out exactly how much, if any, denoising needs to be applied. I'm going to go back to the beginning and let's listen.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean.
So I can detect a little bit of noise, but it's really not anything to worry about. But let's look at what a denoiser will do to a clip like this with a very small amount of noise. And I know this is a subtle example, but stay with me. In a minute, I'm going to show you a much more severe example. So what I usually do is use the audio track mixer, which you can see I have pulled up here. And again, if you don't have this up, you can come up to Window, Audio Track Mixer. And I generally use this for most of my effects processing. You definitely can come down here to the effects panel and drop in specific audio effects, but I find that it's much more convenient and it's faster to process a single track. So once you've made edits to this, once you cut this up and you want to make a change to one of the effects, it's kind of annoying to do it on a per clip level. And so what I would do is use the audio track mixer and process all the clips that I put on audio track 1 together. Over here, you want to make sure that you have this twirl down clicked right here, which will reveal the effect slots and the send assignments. And in the very first slot, because these do get processed in order, I'm going to come down to Noise Reduction and Restoration and choose the effect Denoise. I'm going to double click to pull it up, come back to the beginning, and listen to what it's going to do.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean.
Whenever you apply the denoise effect, whether you put it on a clip or you put it in the audio track mixer, and you start playing your audio, at first it's going to sound like hot garbage because the denoiser is doing whatever it's doing behind the scenes. It's processing the audio, and it's a little bit aggressive when it starts working. But after a few seconds, it kind of settles out, figures out what's noise and what isn't noise, and then it sounds good. Now, the default for processing focus is set to focus on all frequencies, but you could also set that to lower, mid, lower, and high, or just higher frequencies. But I can't recall ever finding very much success with any of these options, so I almost always leave it on focus on all frequencies. So you could experiment with these other options, but I have not found them to be that useful. The default value for amount, I think, is on average a little bit too high, especially for a clip like this, which really just has a very subtle amount of noise. So what I would probably do is drop this down to like 5 or 10% and then play it again. And then what you could do to see what's actually happening is you could use this little bypass the effect button up here. It looks like a power button in the upper left-hand corner. Click this off, turn it back on. As it's playing back, you will hear the audio skip a little bit because this does take some processing and the audio has to catch back up. But you can turn it on and off while it's playing to hear the effect of this processor.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean.
So I think at 10%, it's doing just enough to get that very small amount of background noise. And that's probably what I would do for this clip. Now let's look at a much more extreme example, and that is this clip that you heard in an earlier lesson of Dr. Tom Campbell speaking about nutrition and nutrition studies. So in this example, as you recall, I intentionally edited the clip to represent what would happen if mistakes were made during the production and the audio was not recorded at optimal levels. So there are some clips in here, particularly 2 and 4, that have very high levels of noise.
See how nutrition fits in.
And in this case, what I would do is not process the noise up here in the audio track mixer. I would put denoising directly on these 2 clips and apply it fairly aggressively, something like this. So I'll find the denoiser in the effects panel, apply it to both of these clips. I'm going to click on the first one here, click edit, and I'm going to push this up to about 60% and then play it.
Heart disease is one that gets a lot of attention, and there's no doubt that nutrition can play a significant role. In fact, of all the diseases affected by nutrition, the data on heart disease may be the most compelling.
That is doing a remarkable job. I can hear some artifacts left behind from the denoiser, but like so many things in life, in this case, you can't get something for nothing. You can't remove all of the noise and leave the original audio completely unaffected. Let's check out what's happening on this last clip right here. And I'm going to set this to 70% because the noise is even worse in this clip because the amplitude was brought up about 7 decibels more. Let's listen.
In 1980, a major report suggested that anywhere from 10 to 70% of cancer could be attributed to nutrition. We now have reason,
Again, when it started playing, it wasn't sounding so hot, but once it sort of identified where the noise was, this really sounds pretty good. What I would finally do is apply a tiny bit of noise reduction to this clip right here, because this does have a little bit of noise, and this clip right here, just to match the noise level, because at 10% with a clip that's been recorded with pretty good levels, the denoising is going to be very, very subtle, like you saw in this other clip over here, but it's going to pull enough of the noise out so that the transition point between this clip and this clip won't go from some noise to no noise. It'll go from no noise to no noise. Check it out.
They are among the greatest causes of death and disability worldwide. Let's take a look at a few examples to see how nutrition fits in.
Is that perfect? Absolutely not. Is it impressive? I think so. Now you might be wondering, could you or should you take this clip over to Audition first and process it over there? Or should you just send it over to Audition from Premiere and try and get rid of the noise in Audition? Yes, you could, but should you? Probably not. If the denoising is this good in Premiere, in my experience, it's not going to be any better with any of the other tools that are currently available in Adobe Audition. This denoising lesson is really pretty simple. Use this effect in Premiere, but experiment in Audition if you think you can get better results. You'll do it once or twice and then you'll go, yeah, that didn't really work out, and this effect is fine. And that's pretty much it. Coming up next, you are going to learn how to use equalization in the effects chain. In this lesson, you're going to learn how to use EQ as part of the effect chain for voice. The next effect that I would apply after a denoising effect is an equalizer. And to do that, I'm going to come over here to the audio track mixer. I'm going to click this little drop down in the second effects slot, come down to Filter and EQ, and select Parametric Equalizer. Then I'll come up here and double click to open this up. And let's talk about what an equalizer does. An equalizer adjusts the volume of different frequency bands within an audio signal. And in general, you can use an equalizer in 2 main ways: for corrective adjustments and creative adjustments. In a corrective capacity, what you're doing is you're compensating for any sort of anomalies or weird sounding frequencies that you get maybe using a particular microphone with a particular person's voice in a particular environment. Or maybe you're using something like a lavalier microphone under the clothes, and when you do that, it cuts off a lot of high frequency because sound doesn't penetrate certain clothes very well, and you need to correct for that, and you do that with an EQ. In a creative capacity, you might take something like a voiceover, and you might want to use EQ to make it sound like a cell phone speaker, or maybe an old-timey radio, or something of that nature. And for what I'm going to be using an EQ for, it's definitely going to fall in that corrective capacity. And you might be thinking, yeah, but I heard Josh talk in the previous lesson and it didn't sound like it needed much correction. And you're correct, it doesn't, but it needs some. I don't think I've ever worked on any piece of raw audio that's been recorded that couldn't benefit from a little equalization. And here's the goal. I want to take Josh's audio. I want to get rid of very low frequency information because it's completely useless in this particular case. And I want to find a few different parts of the frequency spectrum that are a little bit annoying and pull those down a little bit. And if there's one part that does sound a little bit better, if I boost it up, I'll do that. In order to get rid of low frequencies, I'm going to use a high pass filter, which is all the way over here on the left. What a high pass filter does is exactly what it says. It lets high frequencies pass, meaning they go through this filter completely unaltered, and it takes low frequencies and attenuates them or cuts them. Sometimes this is called a low cut filter. But you can see what it did in the graph here. And this graph, by the way, represents amplitude in the y-axis and frequency in the x-axis here. It goes all the way up to 20 kilohertz and all the way down to 20 hertz. By default, the high-pass filter is set to 40 hertz with a filter slope, which is the shape of this cutoff here, at 24 decibels per octave, which is fine. But I want to set this a little bit higher because if I play back a little bit of Josh's voice, you'll see in this frequency analyzer here a bunch of blobby bits that represent what's happening in this audio track. Check it out.
For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And
if I pause it, what you'll see is most of the activity is in this range right here. And the fundamental pitch of Josh's voice, because Josh has a male medium voice, is right here. And you won't see this little blob or this little bump here of activity go much below 100, maybe 90 hertz. Someone who has a very deep voice, you may find more activity a little bit below this, but not much. And so I can safely take anything below, let's say 70 or even 75 hertz and get rid of that with this high-pass filter. Anything below here is going to be attenuated at the rate of 24 decibels per octave. Now, 24 decibels per octave means that 1 octave down below 75 hertz, the audio will be reduced by 24 decibels. If you don't know what octaves are, you can think of it like this. An octave below is 1/2 whatever the frequency is, and an octave above is double. It's really pretty simple. So an octave below 75 hertz is 37.5. And anything down in that region, which is right here, is going to be reduced by 24 decibels, which is a good healthy amount. If you had a recording with a lot of like boomy low stuff that was coming from some other noise source, maybe someone in a car running some big subwoofer or something, you might have to click this and select something more aggressive like 48 decibels per octave. But the default of 24 decibels per octave is just fine. The next thing that I would do is grab filter number 1 here and sweep it around like this. So I'm going to pull it up and boost up the frequencies. And I'm mostly going to focus in this range between 100 and maybe 400 hertz because I like to keep these filters in order. So I'm going to take the lowest one, which is not this one marked L here. I can just take that off because I'm not going to use this filter for anything. I'm going to take the number 1 filter and I'm going to sweep it around here, not super high up here, but maybe a 10 decibel bump, and find an area that I think sounds a little bit funny. Let's check it out.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me.
So it sounds like to me somewhere in the neighborhood of 250 hertz sounds a little bit I don't know, nasally, sounds a little bit kind of muffly. So I'm going to take that and I'm just going to cut it just a little bit, maybe 3, 4, 5 decibels, somewhere in that range. And I'm going to do the same operation with filter number 2, but I'm going to start up above where number 1 is.
For me, for as far left as I could see, all the way around to as far right as I could see.
So it sounded like to me 520 hertz, kind of sounded a little bit aggressive, a little bit, I don't know. It tickled my eardrums. And in fact, I made the audio clip there. I apologize about that. I'm going to do the same thing with filter number 3. I'm going to boost it up just a little bit, sweep it around.
Was just massive ocean. And I could see the white caps of the waves start.
And I'm going to cut that down a little bit. You'll notice that all of these cuts, negative 4.6, negative 3.3, 2.2, are all pretty small. And if you're working with audio that has been recorded with a high quality microphone, and the space that you're in generally sounds good, most of the time, this is all you need to do. However, sometimes you'll get a recording that's been recorded in a weird space or with a microphone that just didn't match up with the person's voice. So don't be afraid to get aggressive when you need to. When you do, sometimes what will be beneficial is to decrease the frequencies around this center frequency, which is actually increasing something called the Q. And that way you are not pulling down like a bunch of the audio spectrum. Like this sort of shape here generally would not sound very good.
Starting way out and coming in, I could hear the waves hitting against the rocks.
Because all we have is kind of low stuff and high stuff. But if you make this a little bit sharper, you can kind of narrow in on a particular frequency range that is a little bit more annoying. In general, I think the default values of 2 and maybe a little bit higher, 2.5, are probably where you want to stay for most things. But again, sometimes you got to do whatever you need to do. I want to roll it back to the beginning and see if there's one area that I can find with filter number 4 that might sound good to boost up above here.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just...
So to me, it sounds like maybe if we added a little bit of boost around 10 kilohertz, that might sound nice. And instead of using this filter number 4, what I might do is just disable those and use this filter right here, which is a shelving filter. Basically, it boosts everything else up in a shape that kind of resembles a shelf. Well, it does more so if you click this button here. But I'm going to set that to maybe 9,000, maybe 8.5, something like that.
Changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean.
Maybe just a little bit. I don't want to get too aggressive with it, especially because I'm using headphones right now and I'm not using any kind of corrective processing for these headphones. But once I listen to these with my studio monitors, I may find that much boosting up above 10 kilohertz may be a little bit much. So I'm just going to hedge my bets and just go with something like 2 decibels. That seems like a good value. And this sounds different than it was before. Let's do a little A/B comparison, and I'm going to do that by disabling the EQ and then re-enabling it. Now, one thing that I'm going to do is I'm going to boost the gain here while I'm doing this up about 3 decibels, because this particular EQ effect doesn't do something called equal loudness compensation. And when you use an EQ that doesn't have that feature and you do some cutting, you're essentially just subtracting audio amplitude from the frequency spectrum. And doing that makes it sound quieter. And our brains tend to think that a louder sound is a better sound. So by boosting up the overall gain of the EQ just a little bit, I can more closely match the unaffected signal. And that way, when I bypass and re-enable this effect, the level will match a little more closely. I think 3 decibels should be pretty close. I may have to adjust it. Let's check it out.
For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And I could see the white caps of the waves starting way out and coming in. I could hear the waves hitting against the rocks below me. I could see the giant moon in the sky that was like 5 times bigger than my moon, or at least it seemed. That might be bad science, but
So that actually sounds pretty good. And now that I've done that little kind of loudness compensation there, I'd probably disable this high shelf filter because it did sound a little bit too much. So that's pretty much it. The basic idea is you take a frequency band, you boost it up, you sweep it around, and then you cut it when you find an area that sounds annoying. Now, I will warn you that if you boost this up and you use a very narrow cue like this, and you boost it up a lot, every single frequency will sound annoying. So don't do that. When you start doing this technique of kind of boosting it up and sweeping things around, leave this at its default value of around 2 and just boost it up by a moderate amount, maybe 5, maybe 6, at the most maybe 10 decibels to find any problematic frequencies and then cut them a little bit. And always do a little A/B comparison by disabling and re-enabling the effect to hear if you actually made it better, because sometimes you listen to an EQ'd sound for a while and your brain just sort of accepts that as this is the way it's supposed to sound. And then you take the EQ off and you go, oh my God, well, what was I even thinking? It sounds like garbage. So every once in a while, just do a little reality check and bypass the effect as you're doing these EQ operations. And you should hear a pretty clear, okay, that sounds worse, that sounds better. If you disable and then you re-enable and it sounds worse, you may want to reevaluate or reset some of these filters and start again. Well, that's pretty much it for this lesson. Coming up next, you're going to learn about using dynamics as part of the effects chain for voice. In this lesson, you are going to learn how to use dynamics as part of the effects chain for voice. So I'm picking up where I left off in the last lesson. I'm going to come over here to the audio track mixer, and in the third effects slot, I'm going to come down to amplitude and compression and select dynamics. I'm going to double click to bring that up here. And this effect actually has 4 different dynamics processors in it: an auto gate, a compressor, an expander, and a limiter. Now, 2 of these, the auto gate and the limiter, you can ignore. I'm not going to go into detail about these because there are better limiters that are available in Premiere, and this auto gate is more or less useless. If you want to know more about this effect, check out the Premiere Pro user guide. Instead, I'm going to focus on the compressor and the expander. A compressor compresses dynamic range, and an expander expands dynamic range. Although that's not always the case, that's how they're used here. And first, let's check out the compressor. I'm going to click this checkbox to enable it, and I'm going to show you how to set this compressor up for voice. And I'm not going to go into detail about exactly what each one of these features does. I think it's just too complicated for new users. Instead, I'm going to show you how to set it up to get good results. So to start, take the threshold and set it to 0 decibels. Take the ratio and set it to 4. Take the attack time and turn it all the way down to 0.1 milliseconds. And take the release and set it to 150 milliseconds. Now what you're going to do is start playing back the track wherever there's audio on it. And as it's playing back, you're going to take this threshold and you're going to turn it down until you can see the compressor starting to kick in and reduce the gain. And you'll see this little meter light up here. And what you're looking for is some activity between 0 and 12. For the life of me, I don't know why this goes down to like -40. That is a ridiculous amount of gain reduction. And for pretty straightforward video projects like this, getting around 5, 6, 7, 8 decibels of gain reduction is in the neighborhood of where you want to be. So I'm going to play this back and adjust the threshold.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see all.
Okay, I think that's it. That was pretty quick. My goal was I want to take the louder bits here and I want to see the compressor reacting to those, but I don't necessarily want to see the compressor reacting to these lower level audio blobs. Essentially, we can leave these alone and just take these louder sections here and compress those. So in this case, -15 works pretty well. Really quick, I'm going to jump right here because I can see there's a pretty big spike right here, and I just want to see what this sounds like.
Giant moon in the sky that.
So that's okay. I might just increase this a little bit more to get it to react a little bit less to things that are going to be as loud as this.
See the giant moon in the sky that was like 5.
So really subtle adjustment there. I'm not even sure that it made any difference. So let's just call this -15. Nice round number. Great. And here's what I want to do from here. The compressor is reacting to these peaks here, and it's reducing the gain. That's what this meter is. It's a gain reduction meter. And because it's reducing the level or the gain, we need to make up for that by turning up this control right here, which is the makeup. So let's say it's turning it down by 6 decibels. I'm going to set this to 6 decibels to make up for that gain reduction. And what this is going to do is it's going to push up the audio level back to a comfortable level. It's going to make these peaks about as loud as they were before, but it's going to take all of these lower level things and bring those up as well. And the end result is it's going to be a little bit less dynamic and a little bit more comfortable to listen to. Check it out.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see was.
That sounds pretty good to me. If you want a little bit more relaxed compression, you can turn the ratio down to something like 2:1, or maybe even 1.5:1, but 4:1 is probably as aggressive as I would go for something that sounds like Josh speaking here. If someone was super dynamic, you may have to increase this up even more. But once you get to around 8:1 to 10:1, actually this doesn't even go higher than 8:1, but let's say at around 8:1, this compressor basically becomes a limiter. And the gain reduction that it's doing is so severe that it's not going to really let anything pass up above 15 decibels. So my advice is to stick somewhere in the neighborhood of 4 plus or minus, let's say 1. So now let's look at how to use the expander. So let's enable this, set the ratio to something like 1.5. In this particular case, we don't need a very aggressive ratio to get this to work. And I'm going to set the threshold all the way down to -60. I'm going to bring the playhead back to the beginning. I'm going to play this back and I'm going to push this up. So I'm going to push the threshold up until I can see the in-between bits start to be turned down by this gain reduction meter.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And I could see the white cap.
So I think probably somewhere in the neighborhood of -35 to -30 might work. I intentionally did the compression a little bit more aggressive and the expander a little bit more aggressive so that you could hear it, because sometimes subtle compression just doesn't translate that well, and subtle expansion doesn't translate that well. So let me play it one more time and we can hear what the expander is doing.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to.
If I pick ratio values that are a lot higher than this, the expander is going to react a lot more aggressively. Check it out.
Opened the balcony door and caught this view that just changed everything for me.
At this point, it's sounding more like a gate, which is something that I don't want. That's why I use ratios that are pretty low for the expander, because I wanted to push those low-level audio bits down, but I wanted to push it down just a little bit. I don't want to see 24 decibels of gain reduction on the expander. This sounds pretty good. I'm going to play this back half here and you can see what the compressor and expander are doing.
It felt that way, and it was reflecting off of the ocean. It looked like a Hallmark card. It was unbelievable. And I sat there looking and experiencing this, and I just felt so full of awe and wonder.
So that's pretty much it for compression and expansion. There are better compressors out there and better expanders out there. compressors that have way more options and that might sound a little bit smoother. But this is a great place to start if you're going to stick with the stock audio effects, which you definitely should to start. Coming up next, you're going to learn how to use a de-esser to smooth out those S sounds. Check that out coming up next. In this lesson, you are going to learn how to use a de-esser as part of the effects chain for voice. So, picking right up where I left off in the last lesson, the next effect that I'm going to show you is a de-esser. And a de-esser does exactly what it says. It de-esses the audio. Now, why would you want to do this? Well, sometimes with certain people's voices and certain microphones, sibilant sounds, which are higher frequency sounds created by the human voice, can sound really harsh. When you play them back, it tickles your ear in an unpleasant way. And you may be tempted to come over here to the EQ and find wherever those frequencies are, which are usually between 5 kilohertz and 9.5 kilohertz on the very upper end, and just EQ those down, which is something that you can do, but that will remove those frequencies from everything. And sometimes that's not the best way. Instead, you can reach for a de-esser. And you can find that right down here in amplitude and compression and select de-esser. A de-esser is a dynamics processor. It's going to change the amplitude of your audio. Specifically, it's going to react to a narrow band of frequencies. You can think about it like the compressor is going to be listening to the frequencies where the S is happening. And when it hears the S, it's going to reduce it down. It's going to compress it. So it should only react whenever the S's happen. Let me show you how to set it up. I'm going to play back the audio here, and I'm going to find a spot where Josh is saying S.
As far left as I could see, all the way around to as far right as I could see.
Okay, there's a couple of S's right there. And then what I want to do is I want to click this button right down here that says Output Sibilance Only. And this is going to solo this band, meaning you're not going to hear any of these frequencies or these frequencies. You're only going to hear this frequency range, which is going to sound a little bit harsh. And then in this spectrum analyzer here, you're going to look for whenever your person speaking says an S, and you're going to see where that peak lights up. Let me show you.
As far left as I could see.
Let me zoom in here so we can see where these S's are.
All the way around to as far right as I could see.
So what it looks like, so here's the S right here. And if you wanted to, what you could do in your timeline is press I to set an endpoint, and then go to the end of the S and press O. And then in your button editor, make sure you have this loop playback button pulled down into your toolbar. I'm going to put it right there. Then click OK, and then click this loop button. And then when you play this back, it's going to loop this S, which I promise you will get old in 2 seconds. But it can be a handy tool for identifying where these frequencies live. Okay, can you see where the main spike is? It looks like it's right here. So what I want to do is I want to shift this de-esser up a little bit so that the spiky bit of the S sound is right in the middle of this gap here. And you can see at these default values where the threshold is set to -30, the gain reduction meter is lighting up. It's making a gain reduction on that S of, I think, up to 6 decibels. Almost. We'll call it like 4 decibels. And that's basically what you want to see. You want to find where the S's are and adjust the center frequency. And then you can experiment with the threshold to get more or less de-essing. If I take this off, what I want to hear is I want to hear the de-esser react in a very subtle way, which is kind of hard to try and hear something that's barely happening, but that's what I want. I'm going to take off the loop and I'm going to clear my in and out point, and I'm just going to play this section right here.
For as far left as I could see, all the way around to as far right as I could see, was just massive ocean.
To me, that sounds maybe like it's grabbing on and it's pulling down those S's too much. So what I would probably do is just raise the threshold a little bit, maybe 5, 6, 7, 8 decibels.
For as far left as I could see, all the way around to as far right as I could see, was just massive ocean.
So that was too much. Let me go back down. I'm going to hold control here. Let's try like 27-ish.
For as far left as I could see, all the way around to as far right as I could see, was just massive ocean.
That sounds to me pretty good. Now, honestly, I didn't think that Josh's voice necessarily needed a de-esser, but this is how to use one if you feel like the audio from the person that was recorded is a little bit too sibilant, and sometimes it is. The way that some people produce the S and the particular microphone that's being used to record them is a pairing such that the S's they hit your eardrums and it sounds harsh. Well, that's it for these lessons on the effects chain for voice. This doesn't cover every effect that you'd ever want to use on voice, but this covers the effects that you're going to be reaching for most often. Now, coming up in the next lesson, you're going to learn about some mix track effects that are absolutely essential. So check that out coming up next. In this lesson, you're going to learn about mix track processing. I'm picking up here where I left off in a previous lesson. I have my effects chain for voice set up, and you can see I've made a few changes to my compressor. I've set the ratio to 3, and I've set my threshold on the expander to -33. That's one of the things that I like about working with audio in Premiere. Even though I don't have super advanced tools, I can change things on the fly as my project changes and evolves. So in every project that you do, I'm going to recommend that you use at least 2 effects on your mix track. In the very last effects slot, under Special, load up Loudness Meter. This effect is a meter, so it doesn't change anything about your project. All it does is tell you what is happening with the levels and the loudness and the peaks as you play back your project. And it has some very useful presets. If you click the drop down here, you have a preset for Apple Podcast, Netflix, Spotify, YouTube, and some other ones which I don't think are as useful for most folks. But that doesn't really matter because the Apple Podcast preset here of -16, 21 for low level below, and maximum true peak of -1, super useful. And not just for Apple Podcast. That's a really good range for just about everything that goes on the web. If I set it to YouTube, you can see that things change just a little bit. Now my target loudness is -14 and my low level below is -20. I don't think you really need to worry about low level below. The only 2 areas that you need to focus on are your target loudness and your maximum true peak. So if I switch this back over to levels and I play this from the beginning, I want you to look at the integrated loudness right here, which is going to be what you are targeting, and the true peak over here.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And I could see the white caps of the waves starting way out and coming in. I could hear the waves hitting against the rocks below me. I could see the giant moon in the sky that was like 5 times bigger than...
Okay, I'm not going to play the whole thing because you've heard this like 70 times by now, but we have some useful information that we can work with. My integrated loudness is, well, at this moment, it's 4 decibels off from the target. The target for YouTube is -14, and right now I'm at -18. Now, it doesn't mean that I have to get this project up to -14, because you don't. When you upload things to YouTube, YouTube will do some audio processing on every video. So if it comes in at -16, it's going to bump it up a few decibels to get it closer to -14. So it's totally fine if you don't get it bang on at -14, but I probably want to get it a little bit closer because, in my opinion, I feel better about having heard the processing that's going to be applied as opposed to uploading it to Spotify or YouTube or some other platform and then there's trusting that, well, it's not really close to the range and I'll just leave it up to them to get it there. You don't know what that's going to sound like. I prefer to do it in Premiere and make sure that it's going out at least pretty close to the levels that it's going to be on the platform. So my integrated loudness here at -18, and right now my true peak values look pretty safe, but I don't know what's coming up later in this project. Now this project is pretty simple. There's not a lot going on, but in more complex projects, you don't want to be sitting here staring at this true peak going, okay, is it going to hit over -1? That's crazy. I'm going to target this, and then I'm going to recommend that you insert one more effect right before loudness meter, and that is under amplitude and compression, and it's the hard limiter. I'm going to double click to open that up, and thankfully there's a very useful preset for this effect as well, and it's called True Peak. Now that's kind of nice because most of the presets in most of the other audio effects are fairly useless, but these two seem to have pretty good presets. So setting this to True Peak sets the hard limiter to True Peak mode. It sets the maximum amplitude to -1, no input boost, the look ahead time to 12 milliseconds, 200 milliseconds of release time. This is the same exact effect that Audition uses when you use their match loudness function, and it's the same limiter that is used when you do a loudness normalization on export. So I'm going to just leave these settings as is, and I'm also going to show you a little secret sound clip that I put in here. And this is a little TV static sound effect that I've increased the gain up to 14 decibels to cause it to definitely cause a problem with the true peak. So I'm going to turn this off and I'm going to play this, and I'll warn you, this is going to be loud for just a half a second.
Than my moon, or at least it seemed. That might be bad.
Ooh, did you see that? A true peak of 5.7, that's not going to be great. So I'm going to reset this and I'm going to re-engage my hard limiter here, bring it back before this nasty sound effect, and I'll play it again.
Or at least it seemed. That might be bad science.
Hey, would you look at that? This hard limiter took care of that peak just fine. And I'm in pretty good shape. I don't have to worry about any peaks that are going to pop up later in my project. It doesn't matter how ridiculous I push these faders. There's nothing that's going to get past this hard limiter. Now I can look at trying to get the overall loudness of my project up just a few decibels. A really simple way to do that is to just drive this hard limiter a little bit more by increasing the input boost. So if I just pop this up to 3 decibels, reset this, bring it back to the beginning and play, I should be pretty close to my target.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And I could see the white caps of the waves starting way out and coming in. I could hear the waves hitting against the rocks below me. I could see the giant moon in the sky that was like 5 times bigger than my moon, or at least it seemed. That might be bad science, but...
Oops, I forgot to mute my TV sound effect. No problem there. I'm going to mute that here. So I got that up to -15, which is pretty good. If I want to get it a little closer, I can pop this up to like 3.5. I probably wouldn't do it more than that because I really don't want it to go over -14. -14 already has a very low dynamic range. It's pretty darn loud. So if it's anywhere in this neighborhood, 15, -14.5, it's fine. In fact, I definitely wouldn't push it up another half decibel. I just leave it like this. That's pretty much it. If you don't do anything else, this is what I would do in all of your projects. It's going to protect you from those nasty true peaks that may or may not come up. And it's an easy way that you can take your project wherever the mix level is and just push it up a little bit more so that you can get close to those target levels, whatever they may be. Another effect that you could use, and you don't have to use, is an EQ. And I'm going to load that up on the very first effects slot right here. I'm going to come down to Filter and EQ and grab a parametric equalizer. An EQ is something that is not uncommon to find on a mix track or a mastering track. And if you do use an EQ, you shouldn't be using it for corrective or creative EQ. It should be used just to give a little bit of frequency shaping, plus or minus maybe 1 or 2 decibels here and there, maybe 3 if you really need to. But if you have to do more EQing to your project than that, I would suggest there's probably something that you need to address in one of the tracks. So why did I even put an EQ on here if I don't think this needs to be EQ'd at all? And I don't think it needs to be EQ'd. But one thing that you could do is just disable all of these other filters and then enable the high pass filter and set it to 20 Hertz. What this will do is it'll just roll off super low frequency stuff, and that's pretty much it. You don't really have to do anything else. But if you did want to adjust an EQ, maybe you thought, this could use just a little bit more life in the high frequency department, you might boost this up by just a few decibels, just like this. And let's check out what this sounds like.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And
I'm going to turn that off because I don't really think it needs it. And to be honest, it was a super subtle change. It's something that I would prefer to decide on when I'm listening to my studio monitors and I'm not mixing on headphones, which I'm doing right now. So just a quick note on this loudness meter. This is kind of a cumulative effect, meaning the more you play this, the more this will average the levels. Just because you brought it back to the beginning doesn't mean that it's going to reset everything for you. So as you change things over here, you're going to need to reset this for it to update properly.
I actually left and I opened the door to my room, opened the balcony door.
Now, really quickly, I want to show you one more effect that you may find useful, and that is loudness radar. Loudness radar does exactly the same thing as loudness meter, and I think it's better in almost every way, except for the fact that it doesn't have presets that are useful for modern platforms. These are all old-timey cinema and CD master, if you even know what a CD is. But that doesn't mean that you can't set it up that way. So if you jump over to the settings tab, all you have to do is adjust a few of these parameters here. Set your target loudness up to -14. The radar speed is just the speed at which the meter will go around in a circle, and you can set that to a bunch of different presets. You'll see how that works in just a second. You can adjust your low level below, set your units to LUFS, which makes absolutely no difference because LKFS is exactly the same, and set the loudness standard to BS 1770-3. And then finally, set your true peak to -1. I'm going to play this back from the beginning and let's check out what loudness radar looks like.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And I could see the...
So, do you see why I like this better? It keeps track in the same way that loudness meter does, kind of cumulatively, but it shows you on this very cool looking, radar looking thing, which is really nice. And you can see where in time, relative to where you are now, that you might want to go back and adjust a little part of your mix if you have some really loud spiky bits, or maybe you want to bring the audio down for a dramatic effect. You can kind of more graphically see that here. And you definitely don't need to run both of them at the same time. I just wanted to show you both of them. So that's pretty much it for mix track processing. Now, I should tell you that I don't use these stock effects on my mix track. I use third-party effects, which I'm going to show you in an upcoming lesson. But I want to just say now that there's nothing wrong with this hard limiter or this parametric equalizer. They're very good effects. I just don't use them because I have some more advanced effects that I prefer. And I'm going to show you those in an upcoming lesson. But I wanted to make sure that I covered stock plugins because I know that Not everyone's comfortable or even capable of using third-party plugins. You may be working for a company and the computers are locked down in such a way that you are unable to install VSTs or audio units plugins. I know that's the case at some ad agencies that I've worked at in the past, and knowing how to use stock plugins is really, really handy. So coming up in the next lesson, I'm going to show you a few of my favorite free and paid third-party audio plugins. Check that out coming up next. In this lesson, you will learn how to use third-party audio effects for mix track processing. So like I mentioned in a previous lesson, I don't use stock effects for my mix track processing in my video projects. There's nothing inherently wrong with the stock effects. For example, this hard limiter, which you saw in a previous lesson, this is a fine effect. It works fine, it sounds fine, but I don't prefer to use it because this interface is not that great, because it doesn't have any meters to show me exactly what the plugin is doing. I don't know how much gain reduction is being applied, so I don't know how hard I am hitting this processor, and I have to rely 100% on my ears, which is fine, but it's not the easiest way to work, so I don't prefer to use it. Instead, there are a handful of effects that I like to use, some free, some paid, that I want to show you. And to start, I'm going to show you with an effect that I've been recommending for years, which is called limiter number 6. I'll double click to open that up. And before I jump in and walk you through this effect, I want to briefly cover how to install third-party effects to get them to work with Premiere. Any effects that you want to use have to be 64-bit, and on the PC, that's going to be VST effects or VST3, which I'll talk about more in an upcoming lesson, and on the Mac, that's going to be Audio Unit, or I believe Audio Unit 2. I'm not as familiar with using Mac plugins because all of my workstations are PCs. So in the case of this effect, which by the way is free for Mac and PC, you can download it, and this effect downloads a zip file, and when you extract it, you get a folder, and all I need to do to install this is take this limiter number 6 folder and put that somewhere on my system where I store all of my VST effects. You could leave it in your downloads folder, but it's probably better if you're going to be using third-party effects to create a folder on your system for all of those to live in. So I've done that already. And then back in Premiere, if you go to the audio track mixer and you click on the little flyout here, and then click on Audio Plugin Manager, in this window, you can add that folder wherever you have put all of your third-party plugins. For me, those are going to be VST 64-bit plugins. And on my system, they are on my S drive. You add that folder to this list, and then you scan the plugins, and they will show up in this big list here. You can see that I have just a few. And then you can disable any effects that you don't want to use in Premiere. In my case, I have them all enabled for testing purposes. So let's talk about limiter number 6. Limiter number 6 is a dynamics processor with 5 different modules. There is an RMS compressor, a peak limiter, a high frequency limiter, a clipper, and a true peak limiter. Now, if this seems overwhelming, and I admit this is a lot of stuff, especially for newer folks to audio, don't worry about it. Even though there are a lot of knobs and buttons and switches, there are 2 sections of this plugin that you can more or less completely ignore. I don't ever use the high frequency limiter or the clipper for video projects because I don't find them that useful. And to get this set up, I bet we can do it in about 10 clicks. So on my system, when I load up limiter number 6, it loads the drum bus preset. And you might think that there is a better preset because there are some that are labeled more appropriately, like this one called mix bus, but actually the drum bus preset gets you, I would say 90% of the way there in setting up this effect. So the first thing that I do is I come over here to this last section, this true peak limiter, which is labeled protection, and I come down to the bottom and just click this switch twice. This sets it from digital clip to ISP precise. ISP stands for inter sample peak, and that essentially is the same thing as true peak. So this is now working as a true peak limiter, and the ceiling or the threshold is already set to -1, which will work for my target true peak level of -1 for example, YouTube and many other platforms. I completely ignore the clipper and the high frequency limiter, and then I come over here to the peak limiter, and the only thing that I changed to set this up is I changed the type to C, and I raise the threshold somewhere between -1 and -2. The idea with the peak limiter is that I want this to catch the peaks before they get to the true peak limiter. Reducing the peaks here will give me a cleaner result and probably result in less overall distortion. Then I come down to the gain and I add 3.5 decibels of gain going into the peak limiter. This is a very similar operation to what I did in the last lesson, where I added about 3 decibels of gain in the hard limiter. Finally, I come over here to the compressor and I make some adjustments to make this work for me. Now, this compressor is a little bit different than some of the other compressors that you may or may not have used. This is a very slow RMS compressor, so it doesn't react very quickly at all. And to reduce the gain reduction for this compressor, because I actually don't want this to do that much, what I'm going to do is control click on the gain knob, or you can click and drag to make an adjustment, but I want to set the gain to 0 because this compressor does not have a variable threshold. Instead, to get more or less compression, you adjust the gain knob here and you drive the input either more or less. If you push the gain up, the compressor will compress more. If you pull the gain back, the compressor will compress less. You can also just turn it off with the switch down here, but I'm going to leave it on for now. Then I'm going to adjust the ratio and I'm going to pull that down so it's super low, somewhere in the neighborhood of, well, anywhere between 1.1 and maybe 1.6, because I really don't want this doing a whole lot. Then I'll make the attack as fast as possible, and in this case, this timescale here is in seconds. Normally on compressors, the timescale is in milliseconds, but like I said before, this is a slow compressor. It's a slow reacting compressor, so this is in seconds. So 0.05 is actually 50 milliseconds. Then I adjust the release and I pull that down to around 100, which is 0.1 seconds. That's pretty much it. With those adjustments, this is good to go. Unfortunately, there's not a way to store a preset with this particular effect. With another effect that I'm going to show you in just a minute, you can, but this one you can't. But one way around that, once you get your processing set up, and I don't think I've mentioned this before, is you can create a duplicate of your project. So you can just save a copy of your project and then delete all of your assets from your project, but leave the sequences. And then you will have a really good starting place for your next project. And you won't have to go in and adjust all of your effects for every project. They'll basically be set from your last project. It's a little bit of a workaround for the fact that you can't store presets for audio effects in Premiere, but it does work. So I'm going to click the targeted button here so that this effect remains up. I'm also going to pull up my loudness meter and park that over here. I'm also going to target this so that both of these stay up. I'll bring the playhead back to the beginning and reset this, and let's see what this looks like and sounds like in action.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And I could see the white caps of the waves starting way out and coming in. I could hear the waves hitting against the rocks below me. I could see the giant moon.
So this is not bad. My loudness is looking pretty good. I might have to do a few adjustments to get it a little bit closer to where I want it. One thing that I could do is disable this compressor. I see it kind of jumping in and grabbing some peaks. So let me try it one more time and see how that affects the loudness just by disabling the compressor and letting the peak limiter and the true peak limiter handle, well, just the peaks.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And I could see the white caps of the waves starting way out and coming in. I could hear the waves hitting against the rocks below me. I could see the giant moon in the sky that was like 5 times bigger than my moon, or at least.
Okay, so that brought the loudness up a little bit. I think there are maybe a combination of things that I could do to get this up just a little bit more. I could drive the level a little bit more into the peak limiter, or I could re-engage this and make it react even slower, but maybe turn up the ratio a little bit. Let's see what this will do. And maybe just give this about 2 decibels of gain over here in the compressor.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And I could see the white caps of the waves starting way out and coming in. I could hear the waves hitting against the rocks below me. I could see the giant moon in the sky that was like 5 times bigger than my moon, or at least it seemed. That might be bad science, but it felt that way.
That brought it up by, I think, a healthy amount. Again, I'm not looking to get this right up to -14. I think -14 is pretty darn loud for a lot of things, even though that's the standard for YouTube. Anywhere between -16 and I would say -14.5, I'm pretty good with in terms of getting it close to the YouTube loudness level. And that's a good place, I think, to be for this particular mix. Now, this does look like I'm adding more gain to the mix track than I was in the previous lesson. And that's because I'm using some third-party effects here to do my effects chain for voice for Josh's dialogue track. I made a duplicate of that and I muted the original so that I can go back and forth and show you some third-party effects that I like to use for dialogue, which I'm going to show you in an upcoming lesson. But before I do that, I want to show you another version of limiter number 6, which is the one that I actually use. But before I do that, I want to show you another version of limiter number 6, which is the one that I currently use in all of my projects. Like I mentioned before, this version is great. It sounds excellent. It's got an interesting interface. It's certainly better than the stock hard limiter plugin in terms of what it's actually showing you here. But there is a newer version of this effect called limiter number 6 GE, which is sold by Tokyo Dawn Labs. This is not a free effect, but I have it and I want to show it to you because I think it's pretty cool. So this is under Mastering, Tokyo Dawn Labs, and it's called TDR limiter number 6 GE. GE stands for Gentleman's Edition. I don't really know why it's called that, but that's what it's called. The newer version of limiter number 6 is very, very similar. It has the same 5 modules, so compressor, high frequency limiter, peak limiter, clipper, and a true peak limiter here. But there are about 50 or 60 different things that make this a much better plugin. One of those is a decade or more of development compared to the older version of limiter number 6. But I'll walk you through some of the specific things that I like. One of those is the ability to save presets even right inside of Premiere, which is something that you can't do with every effect and you can't do with any stock effect, but you can do with this effect. And I actually have a preset or 2 presets that I've created. This one here called Bodhi 1 is the one that I use for most of my projects. And it's very similar to how you just saw me set up the free version of limiter number 6. I have my true peak limiter here set to -1. I'm using a multi-band peak limiter with the threshold set around -1.5. And over here, the compressor is, I think, a little bit more useful than the free version because it has a variable threshold and I'm able to set the attack time much faster than the free version of limiter number 6. And there are actually 4 different compression algorithms that you can use. On top of that, there is parallel processing. So You can mix in some of the dry signal with some of the wet signal, or in other words, you can mix together some of the compressed signal with some of the uncompressed signal, which can yield some different results. And this effect has some really good metering in it. In fact, this effect makes it so you don't even really need the loudness meter, because this has a loudness meter with integrated short-term max, momentary, and momentary max, as well as a true peak meter, which does true peak max, true peak, and then 2 variations of PCM peak metering as well. So with this plugin, you'll see that the readings here for integrated will be just about the same after a few seconds once both of these meters has had a chance to analyze the audio.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And I could see the white caps of the waves starting way out and coming in. I could hear the waves hitting against the rocks below me. I could see the giant moon in the sky that was like 5 times bigger than my moon, or at least it seemed. That might be bad science, but it felt that way.
This is the main limiter that I use for my mix track in Premiere and Audition and in Reaper as well. This is a fantastic product. If you want to find out more about all of the features of this limiter, there is a great tutorial video done by one of my favorite YouTubers, Dan Worrall, and you can find that super easily by just searching TDR Limiter 6 in YouTube. Coming up next, I'm going to show you a few more of my favorite mix track processing effects. In this lesson, you will learn about a few more third-party audio effects for mix track processing. So, another effect that you may want to consider using on your mix track is another free effect from Tokyo Dawn Labs. This is called Nova. There is a premium version called Nova GE, but the free version is fantastic. So this is Nova. Nova is a parallel dynamic equalizer, and this effect is super useful. You can use it for regular EQ operations in a very clean and transparent way. You can use it for dynamic EQ. You can use it for broadband compression. It's a super flexible effect. So in the context of a mix track effect, you can use this for some gentle mix track equalization.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean. And I could see the white caps of the...
You can use it in this kind of context for some very gentle mix track equalization. You can use the high pass filter just like you saw in a previous lesson. And there are even more aggressive high pass filter slopes, such as 72 decibels per octave. And one of the nice things about Nova is this effect does equal loudness compensation. So, like I mentioned in a previous lesson, when you use an EQ, if you're boosting or cutting frequencies, this will change the overall amplitude of the signal. In other words, it makes the thing you're EQing either louder or quieter. But Nova has this EQ gain button here, which will enable or disable equal loudness. Equal loudness basically sets the output at the same loudness as the input no matter what you do. This means when you get really aggressive with the EQ, like something like this, the output will still be at the same level, but the effect is that the other frequencies end up being boosted, or they sound like they're being boosted to compensate for the level drop.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me.
So you can see, even with fairly aggressive equalization curves here, the loudness or the signal didn't really change. It was about the same no matter if I was cutting way down here or boosting way up here. Normally with a traditional EQ, when you make those kind of changes, the loudness is all over the place. And this is something that you can enable or disable with this button right here. Another reason why I like this effect and most of the effects from Tokyo Dawn Labs is this dynamic help mode here, which is super useful in figuring out all of the functions of this effect, which may not be obvious at first glance. So anything that you hover here, it tells you exactly what it does, which I find incredibly useful. Another way that you can use this on the mix track is in a dynamic equalization mode. And the easiest way to do this is to start with one of the presets. So if I click the drop down here and I select 3-band dynamic, this sets up Nova to be a 3-band dynamic equalizer, which is very similar to a multi-band compressor. In other words, this compresses the lows, the mids, and the highs independently. And you can set the threshold and the timing, so the attack and the release, independently. And using a dynamic EQ in this way can give you an overall, what I like to call a massaging of all of the frequencies. Let me give you an idea of what this sounds like.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean.
So you can see that certain bands will be responding or reducing the level while other bands aren't doing anything. And it can be a very quick and easy way to get a little bit more spectral balance, if you will, to your mix. Another thing that I like about this effect is that it has a dry mix knob right down here. So if you ever feel like this effect might be a little bit too heavy-handed, or maybe it's doing too much compression, you can use this to really quickly dial back the overall strength of the effect, because this dry mix reduces whatever you have done in the effect and introduces the unaffected signal. So if I set this to 50%, for example, it's going to mix back in 50% of the un-EQ'd or the uncompressed signal, and it's going to reduce the mix of the compressed signal by 50%. So it's basically just reducing the overall effect of this plugin by, in this case, 50%, which I think is really, really handy. Another thing that I love about this effect, and by the way, did I mention already that it's free? This is the free version of Nova, which is fantastic, is that it has a gain reduction delta switch. So if you ever wonder what a compressor is actually doing and you want to hear just the compressed parts, this is the feature that you want to look for. When you click this button in, it's going to let you listen to the things that it's compressing, but only the things that it's compressing. Check it out.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see.
So you can hear that this effect is not doing a whole lot of gain reduction, but you can specifically hear what it is doing. I heard a few of the S sounds trigger this high frequency node right here, and I think that's a helpful feature for compressors to have, because sometimes, depending on how you set the compressor up, it can be useful to hear if the compressor is having any issues with causing some distortion with very fast attack and release times. So for example, if I turn down the attack time really low and the release time really low for the upper frequencies here, in fact, I'll do it with low frequencies as well, I'm guessing that you're going to be able to hear a different quality of compression.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything.
So I think that was pretty easy to hear, that with those particular settings, you can hear the fact that it sounds chattery. Now let's see if you can actually hear that without that switch enabled.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean.
So I think it's a little bit less obvious when you're listening to the full mix, but having a switch like that can help you better identify any issues that you may be hearing that could be coming from this effect. So maybe you set it a little bit more aggressively and you notice that certain bands sound a little bit chattery with super fast attack times like this. That is a great feature to allow you to listen and identify where that is coming from. Because without that, it's very difficult to be able to pinpoint where that chattery or distorted sound may be coming from. So you should be able to hear, I'll roll it back one more time and put this switch back on, and I'm going to adjust these on the fly, and you should be able to hear the compressor relax a little bit more and sound just a little bit smoother.
I actually left and I opened the door to my room, opened the balcony door, and caught this view that just changed everything for me. For as far left as I could see, all the way around to as far right as I could see, was just massive ocean.
Can you hear how those timing changes affected the quality or the character of the compression? It now sounds just a little bit more relaxed and a little bit less chattery. Now, this does mean that the compressor is not going to function exactly the same, but I think this is a handy feature because it lets you hear exactly what's happening. So those are just some basic things that I wanted to show you with Nova. I think Nova is a really cool plugin and I use it all of the time. I use it on my mix track processing. I use it for individual tracks as a replacement for the stock parametric equalizer, although usually I use the GE version because it has some special features, which I'm going to talk about in an upcoming lesson. So another developer that you may want to check out is Tone Boosters, because recently, within the last few months of recording this lesson, Tone Boosters has released all of their legacy plugins, which are these V3 versions of plugins, in what they call a Track Essentials pack and a Bus Tools pack. I think it's called Bus Tools. Anyway, it's a whole bunch of effects that they have released for free, and many of them are very good. And there are a few that work really well for mix track processing. One of them is this bus compressor right here. And I'm just going to disable this and make sure, yep, my compressor is disabled here so that I can show you this Tone Boosters bus compressor. They have a great manual that goes into detail about what all of these settings do. I think it's a pretty handy compressor, especially considering that it's free. It offers a lot of features and it's definitely worth considering. There are a few other really nice effects in that pack as well. There is a compressor here, which you can use on the mix bus. You can use it on individual tracks. I think that's pretty nice. There's an equalizer here that, although it doesn't load with the most useful preset, I think this is actually pretty good. I would consider this as a replacement for the stock equalizer because the functionality of this equalizer is way, way better than the stock EQ. When you hover over individual nodes, you can adjust the Q with your mouse wheel. This seems like such a simple thing, and almost all the third-party EQs that I use, and even EQs in other apps like Reaper, work this way. I don't know why the stock EQ doesn't work this way, but this makes EQing so fast and so handy because you can really quickly dial in the right Q shape for any boosts or cuts that you're doing. And in addition to that, there is a bunch of filters available for each one of these nodes. So this has 6 bands, but every single one of these bands, you can have up to, I don't know, what's this, a dozen different filter types. So low cuts, low shelves, etc. Super, super handy. This is a really, really nice effect. There are a handful of other really nice effects in here. The Tone Boosters sibilance effect is a fantastic standalone de-esser, and there's an effect called Evoke, which is a great effect to use as a single kind of vocal processor. This pack is definitely something that you should check out. Well, that's it for this lesson. There are a few more effects that I want to show you that are really handy for processing dialogue tracks and dealing with more troublesome recordings of people speaking. So check that out coming up next. In this lesson, you are going to learn how to use third-party audio effects to process dialogue. This is Jamise Holly, and this is a real-world example. Jamise gave me permission to use her video to show you how to process a female dialogue track and how to deal with a bit of de-essing. And that's what I'm going to do in this lesson. So to start, I'm going to solo audio track number 1. You can see in the audio track mixer, the only effects that I have running on her voice is a basic denoiser, and it's doing just a tiny amount of denoising. I'm also using TDR limiter number 6, GE on the mix track, and all her dialogue has been loudness matched with the Essential Sound panel. So let's listen to Jamise and see where we're starting from.
When you add value to someone, when you connect, invest, and inspire, they add value to others, and those others add value to others. And as a speaker, it's my mission to start the change reaction that adding value ignites. Hi, I'm Jamise Holly, a Maxwell Leadership Certified Speaker, teacher, trainer, and coach.
Okay, I think that gives you a pretty good idea of where we're starting from. Now, in headphones, I actually think this sounds pretty good right now. But when I was mixing this and processing this before with my studio monitors, which have been calibrated with a measurement microphone, the S sounds sound just a little bit too harsh. Now, this is not Jamise's fault. This is a combination of how she produces her S sounds and the particular microphone that was used, which is an Audio-Technica 875R. The AT875R might be just a little bit more sensitive to frequencies above 10 kilohertz. Jamise also has a presentation that has a good amount of dynamics in there, so this is definitely going to benefit from a bit of compression. And that's where I'm going to start. So the first effect that I'm going to insert here is a third-party compressor, and this is a free compressor called MJUC Junior from a company called Klanghelm. I'll double-click to bring that up here. And this is a fantastic compressor for a number of reasons. It's free, and the controls are extremely simple. There is a compress knob, a time constant toggle, and a makeup knob. So getting this dialed in should be pretty quick. I think this sounds really great, and it does a good job of kind of leveling dialogue tracks. And watch how easy this is to get set up. I'm going to flip this switch over to auto. Auto means a fast attack and an auto release. And then I'm going to play this, dial in some compression and some makeup.
When you add value to someone, when you connect, invest, and inspire, they add value to others, and those others add value to others. And as a speaker, it's my mission to start the change reaction that adding value ignites. Hi, I'm Jamise Holly, a Maxwell Leadership Certified Speaker, teacher, trainer, and coach. As a professional speaker...
Okay, that sounds pretty good. I want to check just a few areas that are particularly loud just to make sure that my levels are okay and I'm not hitting these peak meters here. So there's a pretty big spike down here about halfway through. I'm just going to listen to this one line.
At every engagement, I am determined to...
That looks pretty good. And I'll listen to her introduction again too, because that was pretty loud.
Hi, I'm Jamise Holly, a Maxwell Leadership Certified Speaker, teacher, trainer, and coach. Hi, I'm Jamise Holly, a Maxwell Leadership Certified Speaker, teacher, trainer, and coach.
Okay, I think that sounds pretty good. And like I said before, this is a really simple compressor to use. It's free for Mac and PC, and it's definitely something that I would recommend that you check out. The next effect that I'm going to insert here is by Tokyo Dawn Labs, and this time I'm going to use Nova GE, which is the premium version of Nova. Now, before I open this up, what I'm going to do is just play this back because sometimes what can happen in Premiere when you're using third-party audio effects, and this happens from different developers, not just Tokyo Dawn Labs, but Premiere does not process the audio correctly when it's first inserted. I'll play this and you'll hear exactly what I'm talking about.
When you add value to someone,
You see, that's not right.
when you connect,
But the way to fix this is really simple. Well, it's probably twofold. Number one, go on the bug report and report this problem to Adobe. But secondly, if I just play this and pull this down to a different effect slot, it goes away.
invest, and inspire,
I know that's a really silly thing to have to do because, I'm assuming that you paid for Premiere the same as I did, and it would be really great if some of these things could work the way they're supposed to, but, Adobe's a big company and they can't fix every problem, especially when it's not a particularly marketable thing that they can say, hey, we fixed the audio that should have been working. So to start, I'm going to use Nova as an EQ, and I'm just going to do a real basic and a real quick EQ.
when you add value to someone, when you connect, invest, and inspire, they add value to others, and those others add value to others. And as a speaker, it's my mission to start the change reaction that adding value ignites. Hi, I'm Jimmy's Holly, a Maxwell Leadership Certified Speaker, teacher, trainer, and coach. As a professional speaker, I aim to inspire listeners to live lives of transformation and significance, especially in their relationships.
Okay, I think that's pretty good. Now you may have noticed that I set the high pass filter a little bit higher than I did in previous lessons, and that's because Jamise has kind of a medium female voice, and the lowest pitches that she creates, at least when she's speaking in this video, are not that much lower than about 150 hertz, which you can see on the spectrum analyzer here.
You add value to someone, when you connect, invest, and inspire, they add value to others.
So maybe I could drop this down a little bit more, but you can see that the lowest that we're really getting any energy is about 150 hertz. So I can comfortably get rid of everything below 100 hertz without a problem. All right, the next step for me is tackling some of these S sounds. So to start, I'm going to grab this upper filter here. In fact, I'll just disable some of these ones, some of the filters that I'm not using to get them out of the way. I want to bring this up to where I think this S sound is happening. In fact, I'll just look and see there's a word right here with an S that sounded a little bit sharp. Let me hear that.
Adding value ignites.
Okay. And so I just paused it there and you can see on the spectrum analyzer, there's a spike right here. And so this S is quite a bit higher than where some other folks create S's. And this is what I'm hearing. It's this effect right here that I want to try and reduce. So what I'm going to do is take this filter and change the shape from a shelf to a bell shape like this. And then I'm going to enable the dynamics for this filter by clicking on the threshold button right here. Then I'm going to pull the threshold down and you'll see this little blue line emerge. This is the threshold for the dynamics for this filter. And right now it's set up in the threshold above mode. What that means is that when the audio goes above the threshold, this filter will react. And you can do two different things with it. You can do upward expansion or downward compression. With upward expansion, if I set a negative ratio, what that would do is increase the effect of these S sounds.
Mission to start the change reaction that adding value ignites.
That's not what I want to do. Instead, what I want to do is use a ratio more like 2-to-1, maybe 3-to-1, which will make this a downward compressor.
And as a speaker, it's my mission to start the change reaction that adding value ignites.
So that's what I want this to do. I want it mostly sensitive to this region, and I want this downward compression effect. Now, to make this be a little bit more effective, what I'm going to do is adjust the timing. So I'm going to pull this down pretty fast, and I'm also going to enable this AH button here, which is the look ahead. So the look ahead is not available in the free version. And what that will do is it adds a 0.5 millisecond look ahead, which reduces the distortion, which you heard in a previous lesson when you set the attack times really, really fast. I'm also going to disable the auto release and make it release pretty quick. Maybe 20 milliseconds should work. Essentially, I want this to bite down or react really, really quickly on these S sounds and then get right out of the way. I don't want this filter to remain down and affect anything else. I just want it to hit the S's and then go away. Let's see if that is working.
When you add value to someone, when you connect, invest, and inspire.
Okay, I can see some activity there. It's looking okay. One thing that I think will make this a little bit better is if I enable this side chain button right here. And what this does is it unlinks the sidechain filter from the audio filter here. In other words, it changes the frequencies that this dynamic EQ is sensitive to, such that you could have it react to lower frequencies but compress upper frequencies. Now, that's not what I want to do in this case. What I want to do in this case is I want to change the shape of this sidechain filter to be a little bit more targeted to these upper frequencies. Because without this button engaged, the shape of the filter is also the shape of this sidechain, and that's not what I want. I think it's going to be a little bit more effective if I really target this area around maybe 11 kilohertz or so. And I can actually get a much sharper curve if I change the curves to surgical, which is another feature available in the premium version of Nova. So now it's going to really target just these frequencies here, but the curve that I'm going to be pulling down is going to be a little bit more gentle, which I think will sound a little bit smoother. Let's see what this sounds like.
They add value to others, and those others add value to others. And as a speaker, it's my mission to start the change reaction that adding value ignites. Hi, I'm Jimmy's Holly, a Maxwell Leadership Certified Speaker, Teacher, Trainer, and Coach.
Okay, I think that is sounding pretty good. I might add just a little bit more release here. Now, to verify exactly what this is doing, I can listen to the gain reduction via this gain reduction delta button here.
When you add value to someone, when you connect, invest, and inspire, they add value to others. And those others add value to others. And as a speaker, it's my mission to start the change reaction that adding value.
It might be helpful to raise the threshold up a touch and then increase the ratio because it's grabbing onto a few things that are not actually sibilant sounds or consonants. Let me see if that makes any difference.
And as a speaker, it's my mission to start the change reaction that adding value.
Okay, I think that's okay. It's tough to get it perfect, but I think it's pretty close.
When you add value to someone, when you connect, invest, and inspire, they add value to others. And those others add value to others. And as a speaker, it's my mission to start the change reaction that adding value ignites. Hi, I'm Jimmy's Holly, a Maxwell Leadership Certified Speaker, Teacher, Trainer, and Coach.
I did see one S sound happen that didn't trigger this as much, so I might want to split the difference between maybe 10 and 11 kilohertz and just knock it down a touch more and maybe widen up this filter just a little bit. So one final thing that I want to do in Nova is do a little bit of expansion. Now, this is something you saw in a previous lesson with the stock dynamics effect, where you learned how to do some basic compression and expansion. And I want to do something similar here because I've used this effect to do some pretty healthy compression, which has also brought up the background noise just a little bit. And I don't mean the background hiss or room noise. What I mean is the breath sounds and any other mouth noises that you can hear in the recording. So to do that, I'm going to re-enable filter number 1. I'm going to set this to a high shelf, which normally looks like this, where it boosts all of the frequencies above the crossover in a shape that looks like a shelf, but actually I'm going to pull this down below my high pass filter. And what this is going to do is essentially act like a full bandwidth filter. So I could use this to do some full band compression. That's not actually what's happening, but that is more or less the effect, because in this particular case, you can set this filter down very, very low, all the way down to 10 Hertz. And normally I'm running a high pass filter on my dialogue tracks, and this gives me a lot of flexibility. So what I'm going to do with this is enable the dynamics by clicking on the threshold button, but this time I'm going to toggle it from above threshold to below threshold mode, and this will allow me to do some downward expansion or upward compression. Let me disable these other filters, and I'm going to pull down the threshold. And what this is going to do in its current configuration is when the audio goes above the threshold, it's not going to do anything. But when the audio falls below the threshold, it will reduce the gain. That is an expander, and that's how I'm going to set this up. So I'm going to pull the threshold down to somewhere in this region, and I'm also going to click the sidechain button to unlink the sidechain filter from the audio filter, and I'm going to bring that up to this area between 200 and maybe 500 Hertz and increase the filter shape to be a little bit more sensitive to just these frequencies. The idea is I really only want this to react to the parts where she's speaking and not taking a breath. And breath noises will be up in this region right here. And you can see from this blue line, this dynamics processor is not really going to be sensitive to upper end frequencies. If I wasn't using this, it would be sensitive to those, and it would have a tendency to react a little bit more to breath noises and release that gain reduction, which is not what I want. What I want is for it to be sensitive to this region right here. I'm going to make a couple of changes here to the timing. So I'm going to turn the attack time down, enable look ahead, disable auto release, and set the release time somewhere in the neighborhood of 100 milliseconds.
Add value to someone. When you connect, invest, and inspire, they add value to others, and those others add value to others.
So you can see this is doing essentially exactly what I want. When Jimmy stops talking, this expander is pushing down the audio, and it's doing so in a very smooth way. So let's hear what it sounds like with everything engaged.
When you add value to someone, when you connect, invest, and inspire, they add value to others.
And if I click the gain reduction delta switch and disable this filter, you should hear only the parts where this expander is doing anything. And it should be, if I've set this up properly, it should be just pushing down breath noises. Let's see if it's doing that. I think it's doing a pretty good job. Maybe I could reduce this a little bit more and also maybe bring this up just a touch. Let's see if that will be a little bit more aggressive.
When you connect, invest, and inspire, they add value to others, and those others add value to others.
Okay, that might have been a little bit too much with the threshold. Essentially what I'm watching for is the end of phrases. So when she says this right here, you can see that even with it being pretty heavily compressed, this is going to reduce in level, which means the audio is going to fall a little bit lower here, which means that if the threshold is too high, the expander is going to kick in a little bit, and I don't want that. I want it to remain basically doing nothing while she's talking and then kick in right here. So let's see if lowering the threshold will do that. Yeah, I think that did a really nice job. I heard a nice big breath sound right here, and I could hear it in the expander, which means that it's being pushed down in the expander. Now, if I want this more aggressive, instead of adjusting the threshold, what I can do is increase the ratio, and that should really get this to bite down quite a bit. Good. I think that's working pretty well. All right, let's see what all of this sounds like with the music.
When you add value to someone, when you connect, invest, and inspire, they add value to others. And those others add value to others. And as a speaker, it's my mission to start the change reaction that adding value ignites. Hi, I'm Jimmy's Holly, a Maxwell Leadership Certified Speaker, teacher, trainer, and coach.
I think I might have overdone the de-essing just a little bit, so I'd probably reduce the effectiveness of this by just a little bit by increasing the threshold and pulling the ratio down just a little bit. But I think you got the idea of how to set that up to do some de-essing. Coming up in the next lesson, you are going to learn how to deal with reverb and clicks. Check that out coming up next. In this lesson, you will learn how to remove reverb and clicks. So in this example, I have a project that I shot and edited about a year, maybe 18 months ago. And what you're seeing here was shot on a soundstage. I think it was about a 2,000 square foot soundstage. It's one of those white cycloramas, so it goes back into the distance and you can't really see where the wall starts or ends. There's actually another one over here. So there's a lot of hard surfaces. This room has maybe 20-foot ceilings. It's a pretty big space and it's definitely got some reverb. So what I want to do is loop the first 9 seconds of this project. This is a small little section of the longer video. And I know that's going to get old pretty quick, but I'm doing that on purpose. And that's because after about 14 seconds or so, your brain stops remembering what it heard, 14 seconds ago. So I'm going to let you hear the first couple of phrases here with and without these de-reverb effects. And for de-reverb effects, over here in the audio track mixer on audio track number 2, I have the stock denoise and de-reverb effect loaded. And over here on audio track number 1, I have a third-party denoise and de-reverb effect. The rest of the processing is the same. I have a compressor, an EQ and de-esser, and a peak limiter and kind of leveling compressor set up here with TDR limiter 6GE. So this is the stock de-reverb effect, and you can find it under Noise Reduction Restoration. It's right here, de-reverb. And there aren't many controls to this. There is a processing focus, and right now it's set to focus on all frequencies. There is an amount slider here. Currently it's set to 60%. By default, this loads up at 40%. And there's an auto gain section here. So I'm going to turn this off and on and play this first section a few times so that you can hear what the de-reverb effect sounds like.
And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together. And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together. And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together. And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together.
So I think you can hear that the de-reverb effect is doing a pretty good job of removing some of that reverb. There are some artifacts that I can hear, and there's a little shift in the level of some of the phrases, and I think that's the de-reverb effect trying to attenuate that reverb. There is an auto gain control over here, so you can adjust the amount of gain if you feel like maybe it's not doing a good job of matching the input gain to the output gain. I think overall it's pretty close. Because of the artifacts, I would probably run this a little bit more conservatively, maybe around 45%. So let's check out what that's going to sound like.
And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together. And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together. And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together.
So at 45%, I think it's probably a little bit more of a subtle effect. I think it's working, but it's kind of a balance between how much artifacting you're willing to deal with and how much reverb you're willing to deal with. In this case, you have to pick one. You can either crush the reverb completely out by turning this way up and dealing with the artifacts.
And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together.
Or you can deal with a little bit of reverb and have less artifacting.
And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together. And one thing that...
Another thing that might help a little bit is using an expander to try and reduce the gain or the amplitude at the end of phrases. Right now, I'm not using an expander like I did in a previous lesson. So I do have Nova here, and I have it programmed to do an expander on the first frequency node here, but it's not currently active, so that we can just focus on what these de-reverb effects are doing. So let's compare that with a third-party effect. This is Isotope's de-reverb effect, and this is an older version of the effect. I don't have the current version, which I think is Isotope RX9, but this will give you an idea of the control set that you can find in a third-party reverb and a difference in what these two algorithms can do. So this is audio track number 1, and you're listening to Isotope doing some denoise and some de-reverb.
And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together.
So this is also doing a reasonably good job at getting rid of the reverb. I can hear some artifacting, although this is a different sort of artifacting. It's a little bit harder for me to put my finger on exactly what I'm hearing, but I can tell that it doesn't sound perhaps 100% natural. But that's pretty easy to dial back. All I need to do is reduce the reduction of the reverb here, and it should sound a little bit smoother.
And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together.
This type of third-party plugin has a lot of features. It has a learn mode so that you can set this to learn and you play your audio.
And one thing that happened is that he said the guy just kind of watched him for about 6 months. They doing everything together.
And then it changes all of these parameters. So it changes the amount of reverb in these frequency bands here. It sets the tail length for the reverb. A bunch of things are kind of set when you learn the reverb using this effect, which I think is just ever so slightly more effective than the stock de-reverb, although I think the stock de-reverb really does a pretty decent job. So all this to say that you have some options. There's a pretty good de-reverber built right into Audition and Premiere here, but there are third-party options available. So that's de-reverbing. It's pretty simple. Now let's check out how to deal with some clicks. In the next little phrase here, while Roger is speaking, I heard a couple of clicks. I believe it's right here.
And Mullins said, apologize about what? He said,
and let's listen to this in audio number 2.
And Mullins said, apologize about what? He said, for what my parents told me. They told me.
So in this little phrase right here, I hear just a couple of very small clicks. So let's look at how to deal with these. One way that you can try and address these is just by doing a little keyframe automation. So you can try and find where these clicks are. It looks like there might be a little bit of noise here at the beginning. And then I believe that mouth click is right here. Sometimes these are pretty easy to spot. If it's in the middle of a kind of long vowel, you can see there are 2 little spiky bits right here, and I'm guessing that this is probably the most audible click. This may become some kind of secondary clickety noise in there. So in Premiere, what you could do is you could just try and pull out this section, just pull the volume down. And to do that most effectively, you want to go into your timeline and show audio time units by right-clicking up here in the timeline or going to this little flyout menu here and selecting show audio time units, because you're going to want to zoom in really, really far. When you don't have this selected, the zoom that you can do, especially for audio, you can see that I'm trying to zoom in here. It's just not far enough. It's almost impossible to even see the clicks, I would say about 90% of the time. But you switch over to audio time units and you can get ridiculously close and zoom in here. So that's one way to deal with it. Let's see if that did anything.
Am I on to apologize?
Yeah, not really. Here, I'll back it up one more time for you.
Am I on to apologize?
So sometimes you can get away with that. This technique is a little bit more effective, I think, if the click is in between words, but if it's right in the middle, this is not going to work all that well. So the second thing that I might try is splitting my audio clip like this and then applying an automatic click remover just to this one section. I don't really want to throw it on this entire clip because the audio click remover is inevitably going to try and reduce things that it should not, at least in this particular example. I have had projects where the microphone picked up just a tremendous amount of clicks, and in those cases, I'll actually put the automatic click remover right in the effects rack and leave it on the entire time, because some people just have so many mouth clicks that it has to be done. So I'm just going to search for click, and I'm going to apply the automatic click remover right here. And I usually just leave this at the default settings. With this particular effect, there is no way to listen to exactly what it's doing. You can only listen to the final output. In other words, with other effects, you can output the noise or the clicks to find out if it's attacking some consonants or other parts of the audio that you don't want it to. This you can't. So essentially what I do is I leave it at the default settings. There are some other presets that I think are way too aggressive. And I listen to it and see if it removed the clicks. Now there's one right here, and I think there's another one right here that you can actually see. So let's listen to just this little part here.
Am I on to apologize about what? Am I on to apologize about what?
So that actually sounds pretty good. I'll take this off and you can hear it one more time.
Am I on to apologize about what?
Now, if that's not working for you, the other thing that I do, and this works, I would say 95% of the time, is I manually will go in and get rid of the clicks in Audition. And to do that, all I do is right-click on this clip, come up here and select Edit in Audition. It's going to do a render and replace in Premiere. So the one thing that you want to make sure is that you don't have any volume keyframes that you want baked in. In other words, if I had some keyframes like this and I right-clicked on this and chose Edit in Audition, this little volume automation would be baked in and your keyframes would disappear, but this volume would be kind of locked in to the clip. So that's the only thing that you need to watch out for. That and any effects that you have on this clip will also be rendered. All right, so now that it's in Audition, let's listen to it one more time and see if we can figure out where these clicks are.
Am I on to apologize about what? Am I on to apologize about what?
Okay, so there's one click right here, pretty easy to see. I'm just going to zoom up on it, select it, and then hit Control-U to do that auto heal like you saw in a previous lesson. That should more or less get rid of this first one. Let's hear.
Am I on to apologize about what? Am I on to apologize about what?
Very good. It's kind of a weird phrase. It wasn't articulated very well, but you can hear that the click is gone, and that's very good. The second one is over here. And I can pretty much see it, so I'm just going to select around it, hit Control-U. This is an in-between spot, so I'm not as worried about getting only the click selected because I don't think it really matters in a breath noise here, but that should have gotten rid of it. Let's check and see.
Apologize about what? Am I on to apologize about what?
Now this wave is pretty small. You can see that when it got rendered, it was wherever the gain was set in Premiere, and the peaks for this particular phrase are like down at -21. Now that can be pretty difficult to spot because the waveforms are so small. So one way that you can address that is if you hover over here and you scroll with your mouse, you can change the scaling of the graph. This isn't actually making it louder, it's just making the waveforms taller so that things are easier to spot. You probably don't want to increase the gain because when you save this, it's going to rewrite the WAV file, and then you're going to have one clip that will either be louder or quieter than all the rest, and it's probably best to leave it at the same level. So that's one way that you can get rid of it in Audition, and honestly, that's probably the best way, is you manually search for the clicks, and I'll undo both of those so that you can see where they are again. Usually you will see this kind of waveform here if it's in a vowel, so you see these longer sort of waves, and they're very more or less regular in this word, and then you'll see a big spiky thing that interrupts. Well, sometimes it's not that big. In this case, it's not that big, but most of the time, clicks are high frequency, so it's going to be a tighter grouping of waves compared to the vowel sound here. Sometimes it can be a little tricky to spot, but that's basically what you're looking for, is you want to find those little differences in the waveform, and then you select them. And usually it's best to select a little bit around the click, because if you just select the click and play it and it's set to loop, which it is right down here, it's just going to sound like a weird synthesizer. So hunting them down manually, great way to do it. It is a little bit tedious. Another way that you can go about it is using this diagnostics panel here, which you can find up in the menu. You go to Window, Diagnostics, and in this panel, you will find a couple of pretty useful tools. I think the two most useful that I've used are the declipper and the declicker. Now, the declipper is really pretty fantastic, and that will find any areas in your audio clip that have been clipped, meaning that the amplitude has gone up above 0 decibels. And this does a reasonably good job of recovering those with what I suspect is the auto heal tool, but it does it in kind of an automated way. The declicker does essentially the same thing, where it's going to try and find all of the click sounds, and then you have the option to repair individual clicks or repair all of them. So I'll set this back to the default, and you can see that this is more or less the same exact effect as the automatic click remover, but you have the opportunity to scan, and then it'll try and find all of the clicks, and then you can repair all, or you can select individual clicks and then try to repair them. And you can see that what you and I heard was only 2 kind of offensive clicks. I mean, they weren't that offensive, but the 2 that we were trying to track down, there was one here and one here, but Audition has found 11, and that seems troublesome. Let's see if it actually found any that are the right one. Okay, so maybe this one it found as the right one. And there are a couple of other things that it has identified as clicks, which just seem to be just random little noises or undulations in the waveforms. So, I mean, what you could do is just say, okay, yeah, repair all. Sometimes, though, that's going to be a little bit too aggressive, and it's going to find things that maybe aren't clicks, and it's going to try and auto-heal them. Now, usually it's not going to be a huge deal because the area that it's auto-healing is really, really small, but let's see if that automated way of finding the clicks actually did what we want it to do.
And my uncle said, apologize about what? And my uncle said, apologize.
Yeah, not really. Let me undo that. And I suspect that if I find this one section, yeah, so right here it found the click, it just didn't select enough of it. So sometimes this works, sometimes it doesn't. Usually if I'm having trouble finding where the click noise is, I'll give this a shot, but I would say it's probably less than 50% of the time that it actually works. So again, the best way to do it is to try and find them manually, select them, and then auto heal them. Once you've done that, you can save your clip, and then you can just delete it from the files here if you don't want it hanging out there anymore. And then over in Premiere, you should see it update in your project. And now when I play this, you won't hear those clicks.
And my uncle said, apologize about what?
Okay, that's it for this lesson. Coming up next, you're going to learn how to mix a multi-person interview. In this lesson, you will learn how to mix a multi-person interview. So you've seen a little bit of this footage before in previous lessons. This is Dr. Tom Campbell and his father, Dr. Colin Campbell. This is a project that was shot in my studio, and they're both talking about a book that they co-wrote together 20 years ago called The China Study. And this is a short little example you can see. It's only about 35 seconds long. And I thought it would be a good opportunity to show you how to mix between two people in an interview type situation. This sort of setup here, where you have two people positioned relatively close together and they're wearing lavalier microphones, presents a little bit of a challenge in the mixdown. And that's because they are so close to each other that when Colin speaks, it'll be picked up by Tom's mic and vice versa. Let's take a listen.
Discussing papers with you, for those years.
I remember clearly there were 2, maybe 3 chapters actually. You did the whole package and laid it out kind of, forget which ones they were, but.
And they might have been a little more than 2 or 3.
So the effect is that whichever person is not talking, the other microphone becomes essentially a reverb microphone. I'll solo up Colin's microphone here and just check out what this first phrase sounds like from Tom.
Discussing papers with you, for those years.
That sounds like an on-camera microphone, but it's not. This is just Colin's microphone, and it's way over here. But the thing that you're hearing is you're hearing less of Tom's direct sound relative to Tom's voice bouncing around the room. The studio does have some sound treatment in there. There's a carpet under them. You can see there's panels on the wall. There's panels above them. But it's not magic. And Tom's voice will still bounce around the room, and there are a number of hard surfaces in there. So what I want to do is I want to use some automation of volume to mix back and forth. When Tom's talking, I'm going to pull down Colin's microphone and vice versa. But that's going to get a little bit tricky as we go down this 35-second example because sometimes they talk at the same time. So I'm going to kind of do this in real time, and I'm going to walk you through the decisions and the thought process as I go along. Okay, I'm going to unsolo Colin's microphone, and I already know that Tom speaks first here, so I'm going to preemptively drop a couple of keyframes here and pull down Colin's microphone. And then I know Colin talks here because I just heard it a couple of times. So I'm going to put 2 keyframes here to pull down Tom's microphone, but I'm also going to jump down the timeline to when Tom starts talking again. I've already heard this, and I can see in the waveform here that Tom starts talking again right here. So I'll just drop 2 keyframes right here and then pull Tom's microphone all the way down. Now, sometimes you can get away with not pulling the level of the microphone all the way down with these clip volume keyframes, but in this case, I'm going to need to most of the time because it'll sound the cleanest. I'm also going to come to the beginning here and drop a couple of keyframes here just to fade in this breath noise just a little bit. So let's see what those keyframes have done to clean up the beginning.
Discussing papers with you, for those years.
I remember clearly there were 2, maybe 3.
Discussing papers with you, for those years.
I remember clearly there were.
Discussing papers with you, for those years.
I remember clearly there were 2, maybe 3.
Okay, not bad. Some of the fine-tuning or finessing, if you will, comes in when you are fading between these microphones. Sometimes you're going to have to employ a really fast fade, either fade up or fade down. But in my experience, the quicker the fade, the more audible the transition is between the 2 microphones. So in general, I like to try and keep the fades as long as possible within reason. So when I heard this just a second ago, and I'll play it one more time for you here.
For those years.
I remember.
What I can hear is one of the microphones is dipping down and then the other one comes back up. So let's see if I can make that a little bit smoother by just making this transition a little bit longer. Now, when I'm clicking and dragging here, if I want the keyframe to remain at the same level, so this keyframe is at 0 decibels right now, what I do is after I click it and drag, I hold Shift, and that'll lock it to kind of the horizontal plane, which means it's less likely to go up and down. But if you make a big movement with your mouse, it will snap up and down. It kind of just holds it right at 0 decibel, which is really, really handy. So I think this fade will be a little bit smoother. Let's take a listen.
for those years.
Yeah, I remember.
Great. That sounded pretty smooth. I'm going to keep playing and see what the rest of this sounds like.
Clearly, there were 2, maybe 3 chapters, actually. You did the whole package and laid it out kind of.
I heard that Tom interjects a little yeah right here, but if that's only being picked up by Colin's microphone, it doesn't sound that great. Let's listen again.
You did the whole package.
So that sounds strange. So I'm going to drop 4 keyframes down here, again by control clicking. Usually when I do this kind of mix process, it's almost always 4 keyframes. 1 to start, 1 to end the fade up, and then 1 to start and end the fade down. And that way I can just click and drag the middle section up here to get this to an appropriate level. Now I'm going to push this past 0 decibels because it's kind of low and I want it to kind of poke out just a little bit. And I think in addition to that, what I'm going to have to do is duck down Colin's microphone just a little bit to reduce the intensity of Tom's voice in Colin's microphone. So I think that'll be good. Let me play that and see.
You did the whole package.
That's okay. Trying to get this to be sharper like this, I think will probably be more obvious that I am ducking down Colin's microphone, but I don't know. Let's see.
Did the whole package.
Ducking it down a little bit will make room for Tom's voice to bump in here, and I think that's pretty good. I could probably fade this out too, just a touch like that.
Whole package.
Cool. That sounds a little bit more smooth. I'm going to keep playing here and see what's coming up.
Laid it out kind of, forget which ones they were, but.
And they might have been a little more than 2.
So they switch who's talking here. I'm going to drop Colin's microphone down and let's see what this transition sounds like.
But.
And they might have been a little more than 2 or 3.
Well, I'm talking about,
Okay. Now in this section here, this is where it gets a little bit more tricky because they're both talking at the same time. So Colin comes back in talking here. Tom has a laugh. So I want to bring Colin's microphone back up, but perhaps not all the way because you can see that when I boosted this back up by 5 decibels, this is now quite loud. So I don't think I have to go all the way back up to 0 decibels, probably -5. And then over here, I'll just bring it back up to 0, something like that. Let me see what this sounds like. And I'll also pull Tom's mic down here, but not all the way. If I go down all the way, I think it's going to be really, really obvious that I just dropped Tom's microphone. So I think this should work.
Well, I'm talking about, from scratch the whole thing.
Okay. So I might make this a little bit longer.
Well, I'm talking about, from scratch the whole thing.
Maybe pull that keyframe over to the left a little bit because he's still kind of talking rather loud in this section.
Well, I'm talking about, from scratch the whole thing.
Yeah.
Okay. And then Tom says some stuff right here. Okay. And then Colin starts right here. Again, I'm just kind of going on the fly here. So I'm going to pull Tom's microphone back up to 0 decibels or close. I'm not going to fuss about getting it exactly to 0. That doesn't really matter to me. And then I'll pull Colin's microphone down. Again, I'm not going to pull it down all the way because I think that'll be too severe for this section.
From scratch the whole thing.
Yeah.
You took it.
Okay. That sounded pretty good. Maybe make these fades just a touch longer.
The whole thing.
Yeah.
You took a lot of the stuff.
Some of it.
Okay. Here's another situation where they're kind of going back and forth and it's tough to tell. Let me listen to this one more time.
You took a lot of the stuff.
Some of it, that was based on
I think Tom starts talking right here. He said, well, some of it, Colin's talking here. So I'm going to bring Tom's microphone back up and then pull Colin's microphone down. Let's see if that works.
You took a lot of the stuff.
Some of it.
Okay, I might pull Colin's mic just down a little bit more here.
You took a lot of the stuff.
Some of it, that was based on
Okay, yeah, I think that's working pretty well.
But some of it, that was based on interviews with you and you saying, there's some really interesting.
I don't think Colin speaks again, so I'll just drop this all the way, but maybe make this a little bit longer.
A lot of the
but
stuff.
some of it, that was.
And actually, he says one more word there that I didn't pick up on.
You took a lot of the stuff.
But some of it, that was based on.
Okay, that sounds pretty good. And I might bring in Tom's microphone a little bit more subtly here.
A lot of the
But
stuff.
some of it, I mean, that was based on interviews with
Yeah, that's okay. And also he's quite loud here. So I can probably do something like this where maybe I'll just pull it down by 3 decibels.
But some of it, I mean, that was based on interviews with you and you saying, you know, there's some really interesting.
And then maybe I could boost this area up at the end by just a couple of decibels. You can get a lot of leveling done with a compressor, but sometimes the best way to do it is with some clip volume keyframes like you see me doing here. If there's one word or the end of a word that is lower in intensity and is just not coming through, which happens all of the time, clip volume keyframes are what you need to use to fix that. Not more compression, not more effects, as fun and interesting as those are. It's kind of just brute force keyframe animation, keyframe automation of the clip volume keyframes.
Interesting research from this guy and this and.
Okay, I think Colin actually says yeah right here. So I'm going to pull that up and maybe drop this microphone down just a few decibels. Let's see if that works.
Really interesting research from this guy and.
Okay, maybe a little bit more fade.
Really interesting research from this guy.
And that's probably too loud. I'll just pull that back a couple of decibels.
Research from this guy and this and, you know, there's some interesting stories here and.
Okay, I think that's pretty good. Let me play this from the beginning and see if I need to touch anything up.
Discussing papers with you, you know, for those years.
I remember clearly there were 2, maybe 3 chapters actually. You did the whole package and laid it out kind of, forget which ones they were, but.
And they might have been a little more than 2 or 3.
Well, I'm talking about, you know, from scratch, the whole thing.
Yeah.
So I think this is in pretty good shape. All right, coming up in the next lesson, you are going to learn how to mix dialogue against music. So check that out coming up next. In this lesson, you will learn how to mix music against dialogue. I'm coming back to this example with Jamise Holly that I showed earlier in a previous lesson, and I want to show you my thought process and my workflow for mixing music against dialogue in a simple project like this. So I have a couple of tracks here that I got from Envato Elements. This is one of them. So this will be a good one, I think, for this kind of corporate video promotional piece here. I'm going to drag that into my project. Now, I'm not going to go over how I edit music. At this point, I'm going to show you that in an upcoming lesson, but I am going to make a really quick edit to this. I'm just going to trim off the beginning fade and throw a couple of keyframes here and just do a fade up at the beginning. So you can probably tell, and if you've edited anything with music before, that when you bring music tracks into your project, they are hecka too loud. I don't even need to play this. I think we both know that this music is way too loud. You can just look at the waveform against the waveform of the dialogue here and see, yeah, this is a giant rectangle and it's super loud. So the first thing that you need to do is turn this way down. And an easy way that you can do that is with the Essential Sound panel. So I'm going to pull that up over here, mark this clip as music, and then click Loudness Auto Match. So let's see where the level is now that it's been auto matched. And my dialogue has also been auto-matched, and if I look here in the audio track mixer, you can see I have the same processing applied that you saw in a previous lesson.
When you add value to someone, when you connect, invest, and inspire, they add value to others.
It's close, but the music is still too loud. Now, to get it down even more, you could reduce the gain, or you can use some keyframes. And a really easy way to generate some keyframes is using this ducking feature in the Essential Sound panel. If I enable this, what I can do is select what I want the music to duck against. And by default, it's set to dialogue. And so what this is going to do is analyze the dialogue and then pull the music down, or in other words, it's going to duck the music out of the way of the dialogue. And you can set things like the sensitivity, which is how responsive it will be to little breaks in the dialogue, the duck amount, and the fade time for the keyframes that it's going to generate. Now, I already know from experience that -18 is way too much, so I'm going to drop this to something like -10, and then maybe give myself a little bit more of a fade, something like a second or so, and then click Generate Keyframes. This is going to get to work generating some keyframes for me, and it does so in a little bit of an odd way because it applies an effect called Amplify. And so those keyframes that you saw just a second ago at the very beginning are now kind of gone. I don't know what happened to those. If I click over here, it says Clip Keyframes, but the clip keyframes that it's showing is actually this effect that it inserted called Amplify, which is kind of weird. You can still change the level up here in the effects controls. You can see if I zoom way in, the volume level is still editable, but for some reason, it just doesn't show up down here. I don't really know why, but that's the way the ducking works. With those keyframes generated, let's see if this is closer.
When you add value to someone, when you connect, invest, and inspire, they add value to others, and those others add value to others. And as a speaker,
cool. I think this is a pretty good place to start. It may require a little bit of tweaking down the road, but I think generally this is an okay way to do it with the auto match here in the Essential Sound panel and using this ducking. This is probably even more useful if you're working on perhaps a larger project where you have more breaks in the dialogue. Maybe you're using multiple clips of different people talking and they're on different tracks. Maybe you have multiple music tracks in this project. In a situation like that, using the Essential Sound panel could get you some pretty good results really pretty quickly. However, that's not how I normally do it. What I normally do is create the keyframes manually. I still use the Essential Sound panel most of the time to do an auto match just to get the music in the ballpark of where it needs to be in terms of its loudness. So that is a really good feature. So I'm going to get rid of that amplify effect, which will remove those keyframes, and I'll close the Essential Sound panel, and I'll show you how I typically do it. Now, when I deleted that amplify effect, those keyframes from the amplify effect went away in the clip here, and now what I can do is just do my own keyframes. So I'm going to pull the level to start down to -5 because it really doesn't need to start at 0. And then I'm just going to look at the waveforms here. So the talking bit starts here, and I want this to be at around -10, maybe just a little bit after she starts talking. It's okay if at the beginning of her phrase, if the music is still coming down, I think it'll still be perfectly clear.
when you add value to someone, when you connect, invest, and inspire, they add value to others, and those others add value to others.
Cool. So I think this is a pretty good way to start. Now, it looks to me like this part of the music track is a little bit busier. And sometimes if it's busier and it looks like a rectangle, like this clip does, that can mean that this is going to sound a little bit louder because there's going to be more things happening. So let's see if that's the case in this track.
Inspire listeners to live lives of transformation and significance, especially in their relationships. We are relational.
Yeah, maybe a touch. So sometimes what I do is when I see stuff like this and I listen and I hear that it's a little bit busier, that's going to make it a little bit louder. So I'll pull the level down maybe just a touch here by just a couple of decibels in this case. In other tracks, it may be a bigger change when a different section of the music track comes in or starts, and you may have to drop it down, I don't know, 6 decibels or so or something like that. Finally, I'd come to the end here and bring the music back up right when she stops talking. So this is the last thing that Jamise says.
Tomorrow.
And then just do a little bit of a fade.
Tomorrow.
And then I'll trim up the end of my music and then just do a nice little fade out here with 2 more keyframes. Now, if it looks like I'm going fast with the keyframes, it's just because I've been doing it for a while. I essentially will control click and then hold my mouse on the second keyframe when I'm doing those fades. So I'll do that one more time so you can see. So I control click on the Mac. That's going to be command click, and then I hold the second one. So I'm continuing to hold my mouse, and I'll release control and just drag it down like that. And sometimes what I like to do is take this second to last keyframe and set it to ease out, which makes a little bit more of a curvy shape here for this fade out. Another thing that I do pretty frequently is I will carve out some space in the music track with an EQ. And let me show you what I mean. In the audio track mixer, I'm going to insert a parametric equalizer. I'll double click to bring that up. And what I usually do is carve out a little cut right around 1.5 kilohertz to maybe 7 kilohertz, because there's a lot of speech intelligibility that lives in that range. And so if I can reduce the amplitude in the music, that's going to create just a little bit more space for those consonants and for that speech to live. So I'll take the filter number 4 here and pull it down maybe 7 decibels. Now that's more than I would normally do, but I really want you to hear what's happening here. And then I'll make this curve just a little bit bigger. Again, I usually do like 5 decibels, but I want you to hear exactly what's going on. So I'll just play you the music so that you can hear the effect of this being on and then off. And in particular, I'm going to play it in this section here, which is a little bit busier. So first I'll play it when it's off. So I think you can hear that when it's on, it does sound a little bit more dull, and that was on purpose because I pulled this down too much, but I'll pull it back to about 5 decibels. And what this should do is create just a little bit more space for that vocal to live.
When you add value to someone, when you connect, invest, and inspire, they add value to others, and those others add value to others.
So I don't do this on every music track. I'm not 100% sure that I would need to do it with this music track, but sometimes you'll get a music track that has like a lot of percussion or maybe acoustic guitar, and it's got a lot of busyness that sounds like it's kind of upper frequency, like clicky and ticky kind of stuff. And those sorts of sounds, I think, really compete with speech intelligibility. So with tracks like that, I will usually do something like this. Occasionally, I will apply that effect on the track itself and then animate that cut over time. So if there's a bit of music, 10 seconds of music in the beginning, I'll usually not have that cut. And then right when the person starts talking, I'll fade that cut down. And you can do that really easily. And I'll show you exactly how I would do that. So I just put a parametric EQ over here, and I'm going to do the same sort of cut here. So I'll make a shape that looks like that. And then I'll open up the individual parameters. And what I'm looking for is the EQ band that has the negative value, which is the thing that I just set. And I'll go to the end here and drop a keyframe on band number 4. And I'll zoom in here to where I've done my fade up in the music. And then I'll just slide this back up to about 0. There's no way to input 0 in this particular effect. I don't know why, but that's just the way it is. All right, that's it for this lesson. Coming up next, you're going to learn how to edit music. In this lesson, you are going to learn how to edit music in Premiere Pro. So the track that I'm going to use for this example is actually called Uplifting Synth Pop, but you can see that the track names are a little bit unhelpful. The actual track name is called Full Track. So if you're watching this and you are a music producer making stock music, please name your tracks with the right names, because if I get a dozen of these type of tracks in my project, it makes it very difficult to figure out which is which. So I'm going to pull this out in my project, and I'm going to open up the Essential Sound panel. I'm going to mark this as music and then loudness auto match this just to bring it down to a more comfortable level to listen to. Because if I don't, it's going to be really, really loud, and that's going to not really work very well for us to listen to. Let's get an idea of the musical sections here that we have to work with. I'm not going to play the whole track, but I'll give you an idea of these different musical elements. So this is the intro, and like a lot of stock music, this is in 4/4 time, which means it has 4 beats per measure, 1, 2, 3, 4, and it's repetitive, which means that the chords and the phrases kind of repeat. This section here is basically the same chord progression as what you just heard, but now with big drums in it and a fat melody on the synth. In this section, repeats over and over and over until we get to right here. This is the same chord progression, but just with kind of drums and a synthy bass thing happening. And this again repeats several times. Then we get to a down section here. You can see that this is a little bit quieter. We don't have the big drums because the big drums are the big spiky waveforms here. So now we have kind of the intro kind of pad sound, but with that synth melody on top. And this repeats. And then we're going to go back into that big section with a big drum fill right here. And then this section just repeats several times. And then we go to the end section, which you can see is different just by looking at the waveform. So those are the basic ingredients. That repeats a couple of times, then we have a nice little fade out here. So since I have the Essential Sound panel open, what I'm going to do is click Duration, and Adobe's going to get to work analyzing this. In fact, I think it's already analyzed this because I've recorded this lesson a few times, trying to get this as short and concise as possible. But when you click this duration switch, it will take a couple of seconds to analyze. And now I can use Adobe's Remix to get this song shorter, because you can clearly see it's too long for my project. My project stops right here and the music keeps going. Now I could just trim the end up, fade it out, and call it a day. Sometimes that works, sometimes that doesn't. If you want to get a little bit better results, Remix is a great tool to do that. So all I have to do once this has been analyzed is just drag this duration time down, and I'll hold Shift to get it a little bit closer, faster, somewhere in the neighborhood of 2 minutes. Now it's going to be 2 minutes plus or minus 5 seconds, which is fine. And what Remix has done is make some edits at the end of those musical phrases. So those repeating sections, which are about 4 measures long. So there's 4 bars of 4 beats, 1, 2, 3, 4, 2, 2, 3, 4, 3, 2, 3, 4, 4, 2, 3, 4. And then things repeat. And Remix has made a bunch of edits at all of those spots, and it sounds fantastic. I'll show you by playing the edit points here, and it'll basically sound like nothing happened, which is how you know that it's done a perfect job. See, that basically sounded like nothing, but there was an edit there. That's what this wiggly jiggly line is. Here's another edit. Again, couldn't hear it. Sounded perfect. So I'm not going to play all these, but you can take my word for it that with tracks like this and almost every stock music track, Remix does a fantastic job. Now there are some customization options that you can twirl down here. For example, I don't want this section in this video. This section is just the drums and a synth bass, which I think sounds cool, but I don't think it works for this particular video. So what I can do is adjust this segments and variation slider to try and get this section out of the edit. Okay, well, if I pull the segments down to 1.3, that does exactly what I want. I don't know if I can add some variation back to that. Yeah, not really. At some point, it's going to just add that back. Okay, that actually did a pretty good job. So it's looping this section down here. Let me see where they put the edits. Oh, very nice. Cool. And then the only thing that I need to do to get this to work for me is adjust the ending, because 2 minutes actually doesn't quite work, because this remix feature is not able to detect that this ending part of the song is a fade out, and that does not work over the end of the video. So the end of the video, there's a little call to action, and listen to how it sounds with its current edit.
Speak with me today so that I can speak for you tomorrow.
Yeah, that doesn't work. There should be music here, because this just sounds like somebody screwed up and they picked a track that wasn't long enough. So to get around this, what I would do is just force this to make an edit that's a little bit longer, which it's done, but it's put that drums and bass section back in. So maybe if I twirl these knobs around a little bit, I can get this. Okay, there we go. Now I got it back out again. And now what I can do is trim this back, do my fade, and get this down to the right level, right about there. And I should be good to go. And so now my ending section sounds like this.
I can't wait to add value to you and your audience. Speak with me today so that I can speak for you tomorrow.
So I think that's pretty good, but that's about all Remix can do. It can get you pretty good results. And certainly if you're not a musician and you're not an experienced music editor, it's definitely going to get you way better results than you've ever done before. So that's Remix. It's good, but it can't do the thinking for you. And if you use Audition, there are a few more features that might get you slightly better results, but in my experience, it's easier to do it manually. And that's what I'm going to show you coming up next. In this lesson, you are going to learn how to edit music manually in Premiere. So I'm picking up right where I left off in the last lesson, where I used Remix, and Remix is great, but it doesn't get me where I want to go. Specifically, what I'm referring to is I want to use this track, the same track that I used in the last lesson, but I want certain parts to line up with very specific parts in the video. So I like how the intro is by default, because this has an intro that works really well with this video, and the beat drops at a really good spot. So that's great, but there's this kind of big synth hook here with big sounding drums. That sounds awesome, but it just goes on a little bit too long and it's too intense. And I want to bring the energy down a little bit for this middle section so that I can bring it back up at the end to drive the video home and have a nice, strong closing. So somewhere in this neighborhood, I need to find a transition point to split this video so that I can find a different section to kind of stitch it all together. But before I do that, I'm just going to hop over here and align the beginning. So I'm going to switch to audio time units, hit the tilde key, make this a little bit bigger so that I can see what I'm doing. I'll come all the way to the beginning and just trim up the beginning. There's a little bit of dead space here, and I'm going to show you how to clean that up towards the end of this lesson. This lesson is going to dive into the weeds a little bit, but hang on with me, because I think if you follow this to the end, you're going to learn a little bit about music editing. So you see this shape right here? This is where the big section comes in. And this particular little waveform is going to be very key to being able to split this track up and edit it in a very seamless way. This is the start of a kick drum, and it's got this, at least in this particular track, a very distinctive shape. At least it's distinctive for me. It's this big fat wave right here, which is a low frequency element, which is why this has a big kind of curvy wave shape like that. But at the very beginning, it's got a nice tight little grouping of waves, which indicates a bass drum attack. So a bass drum or a kick drum is a big drum, and the attack of that beater makes a sound that has a little bit of snap to it. And I think that's what we're looking at here. So I'm going to be using the razor tool and slicing that right there. But before I do that, I'm just getting it kind of aligned with this point in the video. This is where Jamise does her introduction, and I want the beat to drop right here because that's going to feel really good. But before I do that, I'm going to manually level this out. I'm going to knock this down by 15 decibels because that's going to be much more comfortable to listen to, and that's just about where the auto match put it. So I think that'll be really good. So I'm going to hop to this section right here. This is where I want the transition to be. And in this track, this has kind of a 4-bar or maybe an 8-bar musical phrase where there are 4 measures, and each one of those measures has 4 beats in it. And at the end of those 4 measures, the pattern of chords repeats. So that's what I'm going to be listening for. So I'm going to play this and help you identify the 4 different chords that I'm going to be trying to listen for. What you're about to hear is the first chord in this 4-measure pattern. So this is the first chord. This is the second chord. This is the third chord. And this is the fourth chord. And right at the end of the measure, where the fourth chord is, which is right here, that's where I want to stop my playhead. And usually what I do is I just kind of count in my head, and then I stop it right on beat 1 of the next measure. So it goes something like this. I'll back it up just a little bit. 1, 2, 3, 4, stop. So right there is the end of the phrase that I'm looking for, and that's where I want to stop my playhead, because if I zoom in really far on this spot, check that out. There's that kick drum shape that I showed you just a minute ago, and this is where I want to split this track, right here. Now, it's not always going to land in the optimal spot, and this really isn't the optimal spot. It would be awesome if that landed right here, so that when these 2 shots changed in the video, the music also changed, and I could maybe get it closer to that point. Let's listen to see what's going on in the music. So I could maybe transition here, so I'm going to zoom way in and find that kick drum again. Here it is. I'm getting really lucky and just kind of parking the playhead right on top of that. So that's another option that might work for transitioning into a different section of this track. Now, the section that I want to use is over here. It's this kind of down section in between. It's about 8 measures long, and I think it's got enough in there where I can loop it a few times in a seamless way. But the first thing that I need to do is identify where I need to start the loop. So I'm just going to play it from right here. Okay, so right there where I stopped my playhead, and I was counting in my head again, counting the beats, right about here is where I want to stop this. Now, this section, I'll play it from here. This does not have a kick drum. All I have to work with is that kind of bass drop sound effect. And I don't really know what that looks like. A kick drum has a pretty identifiable waveform. It's got kind of a nice hard attack, and this sound doesn't. So I'm going to have to try and park the playhead right on top of it and then zoom in and see if I can see what looks like the start of that sound. So I think it's in here. Let's see what we have to work with. Okay, so I might have overshot it. It could be here. It could be here. It might be here. I don't know. I'm just going to take a guess and say that it's here. This sort of timing thing, which is a little bit ambiguous, will become more clear when you try and loop this with another part of the music. Because if this is a little bit off, what you'll hear is as it plays from one section to another section, if I miss this transition point by a little bit, it'll sound like the music just skipped a little bit and it jumped forward, or it either kind of fell behind a little bit. So I'm just going to leave it for now, and I'm going to go to the end of this section. I can see right here, I have that drum fill again, and I'm going to be looking to split this right here, and there's another kick drum shape. You can see that waveform there. And this is the section that I want to loop. I'm going to switch back to the selection tool, and I'm going to delete this part right here. And so somewhere in here, I want to loop this. Let me play this section for you, and then we'll dive into it. So you can see that this section ends with a drum fill. And if I hold Alt and click and drag to duplicate this in the timeline, and then snap that right to this other track, this should loop pretty well. Except that it has that drum fill at the end and that bass drop at the beginning. And that's really not going to work for me. Instead, what I'm going to try and do is find a middle section to loop, which sometimes can be a little bit tricky. But thankfully, this is actually going to be pretty easy because it has that synth melody line. I'm going to use that to try and edit because that repeats. So that section right there, that's what I'm going to be using to loop. So I'm going to zoom right in to that part right there, and I'm going to split it right on that note. And then I'm going to come over here because that same exact thing happens somewhere in this neighborhood. Actually, it might be over here. So that's not it. It's right here. Same exact note, same exact sound. So if I take this section right here and I delete this and I Alt drag this out and then snap this right to the beginning of that other section, and Premiere is not great at snapping when you are in audio time units here because sometimes it won't close this gap all the way. So I like to zoom way in when I snap these clips together just to make sure that it's snapping properly. Check out this transition now. That's basically perfect. So now that I have that set up, I'm going to drag that over here. I'm going to get it close and then zoom in right here so that I can see it snap right to the beginning. And I'm just going to play this section and see how it sounds. I think that sounds pretty good. I'm going to slide that over to see if maybe it would sound better if it was right here because that bass drop was a hair late. Let me see if this sounds better. I think that was better. It's close enough that when I cover that with a cymbal roll, I think it'll sound pretty good. So I'm going to snap these parts back, and this is going to be the section that I loop. So let's see. I'll drag two more of these out here and snap those right there. And then what I think I can do is just take the end of this clip and then just drag it out, which means the beat will come back right here for the end of this video. It might actually be a little bit late, so yeah, maybe if it was here, it might be better. I think that will work. And then I'm going to keep playing here because I want to try and find the end of that phrase again so that I can stitch together the outro of this track. It'll be right here. Right here. So again, here's that kick drum shape. I'm going to split it right there. I'll delete the part on the right, and then I'm going to try and stitch this together with the outro section of the song, which is right here. So right there, and I don't know exactly where this is because I don't know if there's a kick drum here or not. Let me listen to that one more time. Yeah, maybe. So right about here. Maybe it's here. I'll split it there and see if that sounds right. Okay, I'm going to go with that for now. Drag that over here. Zoom up on in here and make sure that that snaps cleanly, because with all of these other items, sometimes Premiere will like to snap the back of this to something and this wave will just get a tiny bit off and that'll totally mess up the timing. So that's why I like to zoom way in here and watch it snap so that I can see that it doesn't jump forward just a tiny bit. So I'm going to play this section here and see what this transition sounds like. I really like that. I think that works well. Okay, I'm going to clean the end up here, and there's a couple more things that I need to do. I'm going to grab this symbol roll, and I'm going to use that to cover this edit point right here. A symbol roll is like kind of a cliche thing to use when you're editing music or doing transitions, but it just kind of works.
To live the confident, purpose-driven lives we are meant to.
Cool. I think that works pretty well. Now there's that bit at the very beginning. If I jump all the way to the beginning, there's a little bit of a gap here, right? Right before the music comes in. And if I play this section, it's not bad. That's not a bad way to start this, but I'm going to show you one more trick. You call this a bonus technique, if you will. I'm going to add another track right down here. So if I right click on audio track number 2 and I add a track, it's going to put one right down below it. And then I'm going to jump to the end. I'm going to alt drag this clip out, and I'm going to find a little bit of audio in the tail, maybe like right here, this section. Doesn't really matter exactly what it is. I'm going to trim it up like this. Drag it down here to audio track number 3, come to the beginning, and then I'm going to go to speed and duration and reverse this. And then I'll trim this up because I want this to line up more or less with the start of the track, just like that. I'll trim this section back and maybe drop the level a touch. I'm going to select the edit point at the very start of this clip and hit Control-Shift-D, which inserts the default audio transition, and then I'll just play this to see what it sounds like. Cool. That's not bad. I think I can probably drop this in level just a little more. I don't know why Premiere has to re-render this every time, but that's what it does. Now to make that a little bit smoother, what I'm going to do is come over here in the audio track mixer, and I'll come to audio track number 3, and I'm going to insert a reverb. Nothing special here. The studio reverb is plenty good for this. And I'm just going to adjust some of these settings. I'll make the room size 100, turn down the early reflections, set the decay to like 6 seconds, turn the width all the way up, turn the dampening down, turn the dry down to, 50, and then I'll make the wet 50. And just with those quick settings, check out what this intro sounds like now. You see that? It's got a little bit of tail on it now. And if I increase the wet and decrease the dry, that's going to make that effect more apparent. Cool. And I think that'll be a nice way to get into this music track. Very nice. I think finally I'll just drop the level a little bit more. Oh yeah, very slick. I like that. The final thing that I need to do is adjust the level of this track here. So I know that this should be somewhere in the neighborhood of probably -10, and then when the beat drops here, maybe I'll bring that down a little bit further, something like that. I think that'll feel right.
Value to someone. When you connect,
actually, I think this can be a little bit louder.
Invest, and inspire,
probably -5.
They add value to others, and those others add value to others. And as a speaker, it's my mission to start the change reaction that adding value ignites. Hi.
Okay. And actually, I think for this, I'm going to leave this up and then drop the level right before she says hi.
Reaction that adding value ignites. Hi.
In fact, I could probably do it a little bit more than that to give it some nice impact.
Adding value ignites. Hi, I'm Jimmy's Holly, a Maxwell leader.
Cool. I think that works pretty well. Now what I can do is take all these clips right here, just select them, and I'll put my CTI over and then use the bracket keys. So I'm using open bracket here, just to drop the audio level. You can see that line moving down. Every time you use one of these bracket keys, it goes down 1 decibel. And then I'll just align that one a little bit better. And then I can probably boost up this. I can probably boost up this section just a skosh. I'm just kind of visually eyeballing it here. Let me see what this sounds like.
To live the confident, purpose-driven lives we are meant to. At every engagement, I am determined to bring that message with.
And then I'll drop this down right here, back down to about -11 or so.
Years now. His principles of growth and communication are time-tested and practically.
Maybe I'll drop this down just a touch more.
Leadership training has equipped me to deliver them in a way that leaves a lasting impact.
Cool. And then finally what I'll do is do a little fade up here at the end and a fade down. Maybe like that.
Today, so that I can speak for you tomorrow.
Cool. I think that works really well. I'll play the beginning so that you can get an idea of how this all came together.
When you add value to someone, when you connect, invest, and inspire, they add value to others, and those others add value to others. And as a speaker, it's my mission to start the change reaction that adding value ignites. Hi, I'm Jimmy's Holly, a Maxwell Leadership Certified Speaker.
This section here might be just a skosh too loud, so I might just drop that a hair, but I'm pretty pleased with this. So clearly, what I just showed you in this lesson is not as quick or easy as using Remix, but the end result is that you get music that works much better for your video. All right, coming up in the next lesson, you are going to learn about using audio submixes. In this lesson, you will learn how and why you might want to use an audio submix. An audio submix is a track that combines audio signals routed to it from specific tracks or track sends in the same sequence. An audio submix is an intermediate step between your audio tracks and the mix track. Let me show you how it works. So in this example, I have Josh speaking, I have some music, and let's say I wanted to add another video to this. Maybe this is a promotion for something, and then I want to show the promotional teaser video. So I'm going to add this video to my project. And I'll pull this down on Audio 3 so it has its own audio track. But this video has already been pre-produced, meaning it's already been mixed and mastered. It's already at the appropriate loudness. It doesn't really need to be recompressed or EQ'd or anything. It's good to go. But the way it stands right now, if this were to play, this track is going to be processed by my mix track effects. And I don't necessarily want that. In fact, in this case, I don't want that at all. So in this example, what I could do is add a submix track, and I'm going to do that now. So if I right-click down here, I can choose Add Audio Submix, which shows up right up here in the audio track mixer. And then what I want to do is route tracks 1 and 2 from the audio track mixer to the submix track. So right here is the track output assignment. And instead of going to the mix track, I'm going to send these 2 tracks to the submix track. And now when I play this, you're going to see the dialogue and the music show up in submix 1 here.
It felt that way, and it was reflecting off of the ocean. It looked like.
So now what I can do is I can take the mix track processing and drag that over to audio submix 1. And then I can delete my mix track processing on my mix track here. And that way, If I play the end of this video, what you'll see is Josh and the music will show up here in Submix 1, and the teaser video will only show up in my mix track.
This, and I just felt so full of awe and wonder.
And that works. Now, the only thing that I want to warn you about is if there is any overlap between different pieces of audio and you don't have any mix track processing, you could potentially have an issue with getting some peaks on your mix track that could sound potentially bad. In other words, you could cause your mix track to clip, and that's not a good thing. So what I would probably do is add one effect to the mix track that will do almost nothing. For example, I could use a stock effect like the hard limiter. It's not my favorite limiter, but it'll work. And I can use the true peak preset, which will set the true peak level to -1, and it won't apply any input boost. The only thing that it's going to do is smash down peaks, and using something like the hard limiter or another true peak limiter is a way to get a little protection without increasing the gain or changing the tonality of your project. So here's another example where I used an audio submix in a project. So this is a podcast that I helped produce a couple of years ago. And in this podcast, there are 3 people talking. There's Peter, Ramon, and Brigham. You can see I have some basic track processing, but instead of routing these tracks to the mix track, I have them all routed to a submix track that I have labeled talk. And I have some additional processing on my submix track. For example, the automatic click remover. And I'm using an instance of Nova to do some really gentle de-essing. And then finally, I'm using an instance of Klanghelm MJUC Jr. to do some very light compression. Because sometimes what can happen in a podcast situation or even an interview situation is you have multiple people talking at the same time, and even though each individual channel might not be peaking, when you combine their gains, it can be a little bit too loud. And so using a compressor in this way, where the ratio or the compress amount is set pretty conservatively, it's really only going to handle very, very loud signals.
I made Ramon go first last time, so I should probably go first this time, right?
That's fine. I had a one-word answer. I was going to say everything, No,
Go ahead.
I want to cheat. No, but
So routing multiple dialogue tracks, especially in a podcast situation or an interview, is a great way to use an audio submix to get a little bit more control, to get a little bit more processing for those tracks. Another example of using an audio submix track is to simply give you more slots for effects. So in Brigham's channel here, you can see that I'm running a denoise, a parametric EQ, a dynamics processor, TDR Nova, and MJUC Jr. It's quite a lot, but sometimes audio needs a lot to make it sound correct. But let's say that this wasn't enough and I needed to individually process this one track even more, which is not a situation that you will encounter very often, but it does happen. In that case, you could use another audio submix to simply route this one track to give you more effects slots. In the same way that I'm using more processing over here, I could just create another audio submix, send Brigham's track there, and then in this case, send that over to the talk track. And that would give me a few more effects slots to work with. That's it for this lesson. Coming up next, you're going to get a look at a sound design project mixed and mastered in Reaper. So check that out coming up next. In this lesson, I'm going to give you a quick walkthrough of a project that I mixed and mastered in Reaper. So you're looking at Reaper here, and this is a project that I did for a local church in the area. They were celebrating their 100-year anniversary, and it's a pretty simple project in terms of the audio. I have some music, a VO, sound effects, and that's pretty much it. I'm going to play it for you and then walk you through how this is being processed and mixed in Reaper.
100 years. A reason to celebrate. But what did it take to make it this far? Faith, courage, love, hope, commitment. What will it take for us to achieve God's future? All He asks is that we are all in.
So that's it. I think this came out pretty well. And a bunch of these assets, by the way, came from Envato Elements. So this music track, which I think worked extremely well, these sound effects here, a bunch of the elements in the video itself, so paper textures and a bunch of the other textures that were used. There's a bunch of light leaks being used, film transitions, kind of lens flare type stuff. That all came from Envato Elements as well. So you saw and heard the project, and you might be thinking, why didn't you just do this in Audition or in Premiere? Fair point, because I definitely could have. But there are some things that are not possible in either of those applications, and getting the same results would just take more time. And that's basically all it comes down to. And I know that you may not have Reaper and you may not be thinking, yeah, I need another audio application. I totally get that. But I want to show you some unique things that I'm doing in this project that are impossible to do with Audition and Premiere. One of those is the way that I am ducking the music underneath the VO track. Let me walk you through how that works. So the effects that I'm using on this music track here are Recomp, which is the stock compressor that comes with Reaper, and a third-party effect called Track Spacer. Both of these are doing some sidechain dynamic processing. Now, you saw some sidechain processing in previous lessons in this course when I was using Nova. What I'm doing here in Reaper is external sidechain compression. So I'm making this compressor react to the VO. And to do that, what I did is I routed the VO track to the audio track. And if I look at the routing here, you can see that right here, it's being received from track 9. So audio from track 9 is being sent to track 8 here. So the audio is coming from channels 1 and 2 on track 9, and it's going to channels 3 and 4 on track 8. Because in Reaper, it's possible to have one track with multiple audio channels. And although that seems very complex to do, it's actually incredibly easy. For example, if I wanted to take these camera sound effects and set up the same thing, it's this fast. That was it. Although it may seem abstract or complex, it's incredibly fast to do in Reaper. So once my routing was set up, then what I did with Recomp is I set the detector input, which is normally set to the main input. That would be how basically every compressor is set up by default, which is to compress the audio that is contained in the track. But by setting it to the auxiliary input, it sets this up as an external sidechain compressor. So as I play this, what you will see is this compressor will be reacting to the VO. So this is the input for this compressor, and this is the gain reduction meter. And you'll see that when the input gets past the threshold, which is right here, you'll see gain reduction, which is being applied to the music. Check it out.
100 years. A reason to celebrate. But what did it take to make it this far?
So you can see the input here was triggering gain reduction, and that gain reduction, again, is being applied to the music, which gets the music track out of the way of the VO. It creates a little bit of room in the mix for that VO to sit. Track Spacer is doing a similar thing, except instead of pulling down the entire signal, what you might call broadband compression, Track Spacer is doing a dynamic EQ. So what Track Spacer does is it analyzes the signal coming in on the sidechain and then applies an inverse EQ. Now, if all of that sounds like hot nonsense, I think it will make a little bit more sense when I play this.
100 years. A reason to celebrate. But what did it take to make it this far?
So the blue line in Track Spacer is the signal that it's analyzing, which is the VO, because that's how this is routed. and the white line represents the inverse EQ. So this is a very similar operation to what I showed you in a previous lesson, where I applied a basic parametric equalizer to a music track to create some space in that music track for the dialogue to sit. Well, Track Spacer, which does exactly what it says, does essentially the same thing, but in a dynamic way. So it's not holding that EQ down the entire time, although you can set it that way with this freeze button. It's dynamically EQing the music track based on what's coming in to that sidechain. And you'll definitely be able to hear this happening if I solo only the music. You can hear that it's being attenuated both in its gain, but also you can hear that certain frequencies are being cut out here and there. And on its own, this obviously doesn't sound great, but with the VO, it just creates a little bit more space in the music for that VO to sit. So it's a really cool way to get kind of a nice, full, thick music and VO mix without a lot of work. Let me walk you through some of the other things that are going on in this project. This is the processing that I'm using on my VO. Now the VO, or the voiceover, came pre-processed, meaning it sounded to me like it was already EQ'd and compressed. So it didn't really need a lot, which is why I'm not doing a ton of processing here with RIA EQ, which is the stock EQ effect in Reaper. I'm just giving it the tiniest amount of boost up here at, 13 kilohertz and a little bit of cut around 280 hertz down here. Nothing fancy, nothing special. It didn't need a lot. And I'm also using this effect here, which is my favorite compression effect. It's called FurComp 2. This is a premium effect, but there is a free version called FurComp 1, and it's fantastic. Now, this effect is a VST3 effect, and I believe it's an Audio Units 2 effect. And using the VST3 version in Premiere is problematic because Premiere does not work with VST3 effects. It causes it to crash, and it hasn't been fixed in the last, 3 or 4 or 5 versions. In the last several years, it's been problematic. But in other applications that work properly with VST3 effects, I use FurComp all of the time because FurComp can do attack times of 0, meaning 0 samples, no milliseconds, with incredibly low distortion, which is fantastic because several other compression plugins, when you set the attack time to 0, don't sound very clean. They have a little bit of distortion. FurComp is not one of them. It is absolutely fantastic, and I use this effect all of the time. So I'm using FurComp here to just knock down a couple of peaks. I'm also using TDR Nova to do a little bit of de-essing, and that's it. And I'm using some effects as well, and I'm sure you probably heard those on the VO. So I have a reverb and a delay. The reverb that I'm using is Cloudseed Algorithmic. This is a free reverb that is absolutely fantastic. It can do ridiculous amounts of reverb. It's very cool and it's free. And I'm also using TDR Nova GE to do some EQ. And over here on the delay track, I'm using an instance of Replica by Native Instruments, which is a delay effect. I'm using RC48, which is a reverb effect, also distributed by Native Instruments, but made by Softtube. And I'm using Nova GE to do some EQ. So the reason that I'm using a separate reverb and delay track, rather than applying reverb and delay to my VO, is that doing it this way, I can apply effects in a different way. For example, if I applied the reverb just to my main VO, it would be more difficult, but not necessarily impossible, to EQ just the reverb, which I'm doing here. Because this track is only doing reverb, I can apply an EQ to this and it will only affect the reverb. That's much more difficult to do when you apply reverb to the thing that you want the reverb on, for example, the VO. Now with the delay, you can see that there is a red line here underneath each one of these media items. This is the send for the delay. So there's not delay on the entire time. the delay is being sent from this VO so that delay only happens on certain words.
100 years.
So in this case, the delay is being sent on years, and so that is the thing that's being repeated. And this is a super common thing to do in music mixing and post-production. It's almost cliche, but I think it works in this case. And finally, let's check out what's happening with these sound effects over here. So these film projectory kind of sound effects, I believe most of these actually came from the video elements, which came from Envato Elements. So I downloaded these film transitions from Envato Elements, and a bunch of them had kind of projector sound effects built into them. And although I could use the videos in Reaper, because you can actually edit video in Reaper, which is pretty awesome, it worked better for me to pull all of those video clips that contained the sound effects into Media Encoder and just create wave files from them. So many of these film projector sound effects, which sound like this, actually came from videos, but I created waves from the videos and then pulled those into Reaper. Some of these are actual sound effects of projectors and things of that nature that I got from Envato Elements as well. And you can see there's kind of an interesting arrangement of these tracks here, and that is using what Reaper calls track folders, which is a way to group and organize tracks and also route their audio. So with this sound effects track folder, I have all of my sound effects in here. All of the audio is routed up through this hierarchy, and I can apply some processing to all of these, although I'm not. But it's an easy way to do multi-track processing, very similar to what I showed you in the last lesson using subgroups. You can do the same thing here. In fact, this film sound effects track is a track folder, and I am processing just the film sound effects with these effects here with an EQ and fur comp. And that's pretty much it. There are a ton of other things that I could talk about in Reaper. In fact, I think this is the 6th or 7th time I've tried to record this exact lesson because I keep getting distracted by talking about all of the cool things and the reasons why I love using Reaper. All right, that's it for this lesson. Stay watching as I wrap up this course with some final thoughts. Thanks so much for watching this course. If you made it this far, you should be proud of yourself because this course covered a lot of ground. And it's my hope that you now have the skills that you need to be able to edit and mix audio better than you ever have before. Make sure to check out the links in the description to get some of the effects that I demoed in this course. Many of them are free and they're definitely worth checking out. If you want to learn more about Premiere, After Effects, Photoshop, Audition, Illustrator, and more, subscribe to this channel and check out the other great content from Tuts Plus and Envato on YouTube. And if you want access to millions of creative digital assets for one low price, check out Envato Elements. With Envato Elements, you get access to stock footage, motion graphics templates, music, photos, vector graphics, fonts, sound effects, After Effects templates, and so much more. A single subscription gives you access to everything you need to create great projects. See it for yourself at elements.envato.com. Thanks again for watching this course. Let me know what you thought about this course down in the comments. And if you liked it, give this video a like and consider subscribing. My name is Dave Bodie for Envato, and I'll see you around.